Good afternoon, good morning, good evening, wherever you might be in the world. We're still waiting on Tom. Tom the Tardy, as we shall call him from here on in. Good evening, gentlemen, and a very good evening to Samuel. Quiet. All right. No good evenings then. That went very well. That went really, really, really well, that bit. Very good.
Can we have a new MC, please?
Yeah, you can. You can. So, the first thing I was going to kick off, Richard can't join us because tonight, which is a shame. He was going to, but he chickened out because he was afraid of the ribbon that he was going to get. But Devon, East Devon, and I'm sure we've all seen their airspace grab that they're going for, and they continue to go for. And Richard's actually pulled some data from Altitude Angel for the flying that's happened in East Devon, which was very, very interesting, and put it on a map. So we'll part that. Oh goodness me, we're getting the whole Kraus Empire's arriving. Good day, Stefan.
Hi, how are you doing?
Very well, thank you. And yourself? I have your Mrs. Balls on the shelf, ready and waiting for you.
That's wonderful. I miss that stuff. My goodness.
Yeah.
And a good Devon curry. Well, thanks for having us on the show, guys. This is tremendous.
Bunny chow, absolutely. Now, is Tom with you, or are we still waiting for Tom?
We're still waiting for Tom.
Guys, I don't know. Shabby.
That's
Shabby.
the problem. That's the problem with soaring. You know when you take off, but you never know when you're landing. So that's the problem of soaring.
Oh, God. We were talking just before we started. So for the guys that don't know, it's Samuel is the hero of Ardusaur. He dirt man, as the young folks say. And if you don't know what Ardusaur is, it does what it says on the tin. It allows you to do autonomous soaring with you. And with that, that was enough to send him away. I didn't mean to send him away, but it allows you to soar. Even things like Bixler, you can core autonomously. Yeah, he's coming back. You can soar autonomously, and I've used it in the past for keeping our radio repeaters airborne for when we're looking for collared animals here, where I am in South Africa, and it was very good for just increasing the endurance of a very, very simple platform. I can't remember what it's called. Can anyone remember what that supersized Bixler was, like the 2.6 meter one? That's what I had it in that, amongst other things. And here's Tom the Tardy. Good evening, Tom the Tardy.
Sorry, guys.
Must be a several-minute time delay. But we're just introducing Ardusaur, which you guys have been involved in, with that live stream of your crawl up to height the other day, which is very, very interesting. But maybe, I don't know, how should we deal with this? Do you want to start telling us, one of you three want to start telling us about that aircraft and where you are in your test program?
Yeah, maybe good spot for Stefan. Give us the whole corporate spiel.
Sure. So again, guys, thank you so much. So I think what's very important to note about Kraus and Lanny Aerospace is we really tried to, we looked at the markets for aircraft in our size and weight category and really tried to address the shortcomings in the industry when it came to two very important things. And the first one was endurance. So what we did is we tried to create and have now successfully brought to market an aircraft that has an extreme endurance envelope. But what's very important to note about that is it's not just about flying an airplane and flying it for a long time, but it's about flying an airplane for a long time that is operationally relevant with high-powered radios, that are mil-spec or something that can deliver to a specific requirement for a high-end customer. And second from that, by having the ability to power an operationally relevant payload, whether that be for surveillance, intelligence, reconnaissance, for example, or as we call it in the industry, ISR, intelligence, surveillance, and reconnaissance, provisioning of communication services like 3G, 4G, and LTE types of services for people on the ground, or other type of bespoke payloads. So it's the whole coming together of all of these different systems and providing that in a system which has the ability to endure while actual airborne. And further from that, a system which has the ability to operate in various conditions and at range. So when I say at range, we all suffer from this problem of line of sight, and typically it's very short. If you look at the competitive landscape again, it's just a few kilometers with their communication, their command and control systems, and for the payload systems. So what we've done is we have unified both our command and control and our payload data into one single communications link, and given the operator the ability to fly typically unamplified 60 kilometers away from the ground station to the airplane in terms of distance, and up to 200 kilometers line of sight capability when you look at power amplification and providing extended range to the operator. So those are some of the main things which we have solved for with the aircraft, the K1000 ULE for the industry. And I see we're just joined now by my co-founder, Fatima Hamdani. So welcome back to the show, Fatima.
Hey, Fatima.
I feel like we're being ganged up on. Did you feel ganged up? I feel we're being ganged up on.
Sorry.
Okay, well, no, that's all right. Chaps, I say, before we started, the blokes were telling me autonomous soaring is rubbish. So FPV rules. Bruce, do you want to tell us why autonomous soaring is rubbish? And then maybe they can defend it.
Well, it's a high-tech solution to a low-tech problem. Balloons, kites, other things probably in many occasions would be far more effective than a soaring craft. And I like to fly. I don't like to just watch a computer screen all day. I'm a flyer. I don't want all this automatic stuff. It's like being in the backseat of a bus when you should be driving.
Yeah, but we're lazy. We like to do the fly and forget and just get the service provisioning from the platform, right?
I think we're also talking about two different worlds, right? We are kind of trying to address and cater to. Actually, I don't want it dependent on operators or pilots or folks who love to fly, because we want to enable intelligence and aerial intelligence and actionable intelligence, with the motto of the company being, hey, how can I shrink the gap between aerial intelligence and decision making so that lives can be saved?
I like to note that the motto of the company does start with "Hey."
There you go. So, and so that's where I think there is a different world where everything from a first-person view perspective, yes, you love to fly, so you want to fly. For our perspective, it's about aerial intelligence and how effectively we can do that.
Yeah, it's really all about tools, right? If it's going to be a tool, it has to be automated. Manual tools are, nice robots. But it's the same thing as if you had assembly line for cars and they had robots doing it. But if someone was driving those robots, then it sort of defeats the purpose. So even though drones, put the tools in the sky, which humans can't be at, having the autonomousness of it makes it so you don't need a one person per vehicle type of scaling. So this being fully autonomous, you can scale it up, right?
It's pretty unpredictable, isn't it? Because you're highly reliant on things like thermals or wave lift or slope lift and wind and things. So how do you know that a mission that you start you can complete?
Yeah, so that's where I think, and I'll let my team kind of add in there. But from a business perspective, how I address that is mission is critical, right? We're always mission focused, so that trumps everything. In performing the mission, if I can use environmental conditions to my advantage for updraft and flight so that I can reduce the amount of thrust I need and conserve power, and while I'm doing that, also have things like solar panels and or photovoltaics that recharge my battery while I'm flying, that kind of, all of that additive components give me the long endurance that allow me to cover large areas.
I'm just going to ask something, because recently there was an announcement here in Portugal about a deployment of VTOLs to do forest fire surveillance, and they opted to get petrol engines because they can endure 12 hours on the pattern that they want. So that is a problem that is solved easily with the two-stroke petrol engine. Why turn on the complication of autonomous soaring, solar panels? Aren't we just over-engineering?
No, because one of the things you have to account for, there are couple of, and what's very interesting is we were just on one of our military defense calls. We also do work with them. And all of them have ample budgets and money, and they have invested in. When you talk about 12 hours on a fuel, first I want to know which platform you're referring to, and how much does it cost, right? And
I can tell you that 12 it was a contract of 4.5 million euros.
And the logistics to that too. Remember that?
Yeah.
Yeah. So the footprint. So I usually like to boil it. I have a simple mind. I like to boil things down in simple things, right? There are 4 things when you're talking about a fixed wing. One is how far it can travel from the operator, how long it can stay up, how easy is it to integrate things into the UAV, and for the UAV to integrate with other assets that are deployed, machine to machine, human to machine teaming. And then finally, how easy is it to operationalize it? If you are going to need 10 to 15 people to operationalize a platform, what you might, in the CapEx investment you're making, you have a 10x OpEx investment that goes with it, which is ridiculous. Yeah. I'm talking about a 2-man team, put it up, and where we're taking our perpetual flight is nonstop flight. You talking about 12 hours, I'm talking about 24 to 36 hours at 1/4 of the cost of what they would ever pay with a fuel-based engine. And the servicing, the repair, and the mean time to failure is all higher as soon as you're talking about a gas engine.
Yeah, not to mention the...
How do you get to that? How do you get to that pricing? Sorry, for the fuel-based one. How do you get to be? Just explain that again. Maybe I wasn't listening hard enough. That you're that much cheaper.
It's very important to note. Your mean time between failure with the gas-based engine. There's so many moving parts associated to that. There's so much more logistical thought and process that needs to go behind operating a simple electric motor versus a fuel-based guzzler, which does fail. And also, one thing which I did mention earlier was the logistics component about fuels. A lot of our customers, have gotten very tired about having to get special fuel oil mixes, special fuels to different sites, whether that be propane or 2-stroke or regular fuel. There's a big push toward when it comes to motorized aircraft or heavy fuel, for example. That cut down a lot of the logistics aspects because that's just readily available in most places. So if you look at just think about this: your 2-stroke aircraft needs special fuels, special type of oil mixes. That if you get the proportion wrong, you've got a problem with the motor. It's not going to fly. Electric solves for this. It really does. It's a big consideration.
I certainly get that now. Yeah, that's absolutely.
But transporting lipos is a bit. Ask Louis about transporting lipos. That can be a bigger problem than sourcing fuel.
No, you're mute.
Don't tell me anything about transporting big lipos because it's a real pain in the geography to get big lipos from one place to another in an efficient way, especially when you have an ocean to cross with 48 batteries that are way above the 100 watt-hours cap. So it is much easier to carry a petrol engine. I'm so sorry that our company vehicles don't have petrol engines. It would make it so much easier, but then it's the price you pay for versatility of the batteries. I was just referring for something completely different because I'm just looking at this announcement from the government here: 4.5 million euros, 12 VTOLs, 12 hours autonomy, and it is a petrol engine. Not much.
That seems super cheap, doesn't it? I mean, if there's 12 of them, then there's at least 12 people operating them if they're distributing them. So how much money are they earning? That doesn't seem like a very accurate price. I mean, what's the daily operating cost of that, I wonder? Talking out loud. Obviously.
No. I'm just trying to read between the lines here, but I'm just seeing the specs. The payloads, they're fully loaded with payloads and everything, but the kitchen sink, it's here, and it's also a VTOL. So apparently they went the VTOL route. So that would make it
We-
a hard vehicle for Samuel to make flying as a sword, a VTOL, right, Samuel?
Well, surprise, we're working on it. That's one thing that's on our roadmap. So I think there's some really good points there. And I think the first thing to say is autonomous soaring is a technology like any other. It doesn't solve every problem, but it's a tool in the toolbox. And for us, what we've done is we've chosen a suite of technologies for our platform. So autonomous soaring is obviously one that I'm very heavily involved in. But yeah, we're also using solar power as well as good battery technologies to give ourselves very good performance in a range of conditions which are important to our customers. And there are some other constraints that they have on their operations. So, for example, operating from ships and in certain environments where gasoline or petrol-based propulsion isn't acceptable or attractive, which then pushes them down the heavy fuel engine options, which start to carry a very high cost point and maintenance burden. But I think for me, the biggest attraction of the electric, solar, and soaring technology mix is that it really allows us to push way beyond the capabilities of internal combustion engines, especially when we're looking at our upcoming platforms. And I'll explain what I mean there is right now we've demonstrated 12 hours of endurance on an operationally relevant platform carrying cameras and radio systems. But that's really just the start of where we're going with this. So once you get the capability to fly through a day-night cycle, so harvesting energy during the day by soaring and by solar panels, and then storing that for flying through the night, both in terms of altitude and battery energy. So then making it into the second day and then going beyond that into multiple days of endurance. You quite quickly, once you reach that level of performance where you're going through multiple days, there really doesn't seem to be much of a boundary in terms of how long you can go for. So you're limited still by geography in terms of the latitude bands you can operate in and times of year, and that's just a fundamental aspect. But you can still get to very, very long endurance levels that can't be matched by any internal combustion solution. And those, some of those mission profiles that I'm talking about that are important to our customers are kind of uniquely fulfilled by that technology mix that we're bringing to the market.
Your operational envelope must be much narrower than the petrol-powered plane, for example, because if I said, what's your endurance over a flat ocean on a cloudy day, you probably couldn't compete with petrol, could you? And certainly, remember, the petrol craft can be a lot smaller, easier to manage, because if you're going for that solar panels, you've got to have a fairly large wing area. That also adds to your loading. It makes it more difficult to launch, makes it more difficult to store. And we're talking about fuels on boats and things. You can get a lot of time out of a couple of 20-litre jerry cans of petrol, and they're not hard to store on a boat.
So I would love to actually, all of those components have been tried out. We've worked with the Royal Navy and others that have decommissioned some of these petrol-based platforms. So exactly what you're trying to say, because even if with VTOL, the landing and launching, and when you see the footprint of the platform itself, we are no bigger actually than the footprint that they have to transport on. Those are really heavy platforms. Again, operational footprints of those platforms on a deck is ridiculous. One of the reasons why they were decommissioned off of every frigate that the Royal Navy is flying is exactly because of those components. And we're talking about reputable companies that have been decommissioned because of that. So they're actually coming to us. And that's one of the reasons why we are looking to integrate the VTOL module before the end of this year. Of course, it'll be an endurance hit, but that allows us to actually perform with some of these characteristics. And that's where our perpetual, what Sam said, when you have a network effect of these different components coming together, I'm performing in some of the worst conditions at a 12-hour endurance easy with my perpetual.
Yeah, and Bruce, to answer your question more directly, in terrible conditions with no solar energy whatsoever, the worst case is about 4-hour flight on our vehicle with everything turned on. And then in favorable conditions in just battery, it is about 6 hours. So we expect about 5 hours no matter what, generally speaking. And that's a typical flight. And then when we have solar on that, Sam might speak to what our worst case cloudy conditions are. But just those two give us all day long, essentially. Right.
So perhaps an hybrid solution where you could have a petrol engine working as a generator for an electrical system wouldn't be more versatile, perhaps?
Yeah,
Just
the Holy Grail really would be a fuel cell solution. So right now, because we've optimized for very low power consumption, a fuel cell, battery, solar, and soaring combination would kind of fill the bracket that I think you're talking about, where you have very, very poor conditions and you're trying to get extended range. Unfortunately,
if you can't carry petrol, how are you going to carry hydrogen, compressed hydrogen, or other fuel cell, fuels?
Well, I'm talking about a heavy fuel cell, which doesn't currently exist, but that would be an ideal technology to go with our other technology components. And that's something that's being actively worked on in the marketplace. So I think it's going to be one of the things on our roadmap to integrate down the line. And heavy fuel is definitely going to be the preferred energy source for that situation where we have very little atmospheric energy or solar energy to harvest, which would be a kind of worst case scenario.
So looking at the thing, you've definitely got a niche in the market. I guess the really important thing is how big is that niche compared to the general market that you're competing with? You've obviously got benefits and things you can sell on, but how much of the market do you think that this technology will take from the more traditional solutions?
Well, I think there's two aspects. So there's the existing market, but there's also all the markets which aren't currently being filled because the platforms don't exist to provide very persistent sensing capability. Which a lot of the applications aren't necessarily extremely sensitive to when you provide that capability, but it's more about gathering data on an ad hoc basis. So, for example, climate change modeling would be a big one, or atmospheric monitoring, where having a sensor up there at some point in time is a valuable thing. And if there are periods of time when the weather is poor and the platform's not there, then that's not necessarily a massive downside. But certainly in terms of the current markets as well, I'll let Fatima speak to that, but we're seeing some very large opportunities because a lot of the platforms we're competing against rely on some pretty unattainable fuel sources, such as medical grade propane or hydrogen for fuel cells, which brings a whole load of logistical challenges.
It's a shame we don't have someone who knows about balloons, because they could tell us whether you could have a balloon that was controlled in the same way and had virtually infinite flight times with a very small amount of fuel. Do you know anyone, Gary, who could comment on that?
No, I don't know anyone that's had any balloon experience at all. Well, look, what the Google Loon guys doing is quite extraordinary, actually, with their technology, and people have laughed at them, but they're plodding away, and it's working, and it's deployed, and it's certainly when these guys form part of the HAPS Alliance, and we're supposed to just be saying, actually, gentlemen and ladies and gentlemen, it's just cool. Autonomous soaring is just cool. I won't have a bad word said. It's just bloody cool.
Yeah. I would say when. Oh, go ahead, Gary.
Go on, Tom. No, go ahead.
I'll just say, like, one thing that balloons are really good at is the multi-day sort of thing, because you're kind of forced to, while you're up there, you might as well stay up there, kind of idea. And what Sam was talking about earlier was things that we're trending towards on our future products is vehicles that can not just last the day and night cycle, but then there's no end to it, right? You're up there for many days, many months, whatever. And since you're a pure electric regeneration vehicle, then you don't have to worry about the fuel problems. There is no fuel to generate electricity or none of that. So you can actually be up there indefinitely if you wanted to, with the only limitation being maintenance.
Sorry, Tom, but who has the most data in the world now, by far, about upper atmosphere stuff, should they desire to launch an aircraft themselves, is the Loon crowd. No one else will have the amount of data about how the upper air works. No one will be able to beat them now because they've got years worth of data, and they'd be very well placed to dive into that.
NASA's been doing that too, but yeah.
No, nobody's NASA balloons are rubbish compared to the Loon ones because they just let them go, and that's that.
Do tell.
Guys,
No, they aren't. No, they're very simple. They're very simple systems. But Loon, they've definitely got the maneuvering. If you just watch them, I mean, some people that don't get out much and don't have a social life might actually watch them a bit on Flight Radar and the like, and watch them maneuvering them, and it's flipping impressive from a balloon driver's point of view.
And that's
The
just jumping
position
altitude
of-
and come back, and you're doing
Yeah,
this, right?
but I mean,
Altitude.
that's yeah. But that's not as straightforward as it seems. And NASA doesn't
You're
do
right.
that. They just let go of them. Off they
One
go.
very interesting thing that I found about the balloons is while they do have the ability to navigate them, their ability to precision station keep is just not there because they are vulnerable to the winds and the current.
Yeah.
So there's one, big, I think, thing we need to just discuss here. While we are building perpetual airborne systems, they have the ability to precision station keep. A balloon is fantastic for certain applications and we have for others. I think
Sure.
both have their merits and they both serve different markets. While both are up there for very long times, they do very different things.
I think
There is overlap, however. I just want to just highlight that.
And Steph, what you're saying, I think I'll add to that, right? There are different applications for different components. When you do have to do station keep, I think Sam brought up the climate change monitoring. We were sitting with the National Geospatial Agency, and they were like, we haven't had the ability you guys are bringing to us where you're station keeping and then eventually perpetually station keeping across all different altitudes. Try flying a gas-based engine at 20,000 feet, MSL. Not happening. But when we are climbing up in altitudes and station keeping, I don't think it's one or the other. It's a complementary. And even right now, when we are working on certain mission profiles, and I can't go into the details, it's a multi-domain mission profile, which includes high altitude balloons, which includes what we can cross all the different altitudes and even backhaul of data and comms, and then lower assets that we can extend in their functionality because of what we provide on top of that, right? So that
part of a big jigsaw, aren't you? It's you can, as long as you all speak the same radio language, or there are common communication systems standards between these HAPs rather than closed systems. And I mean, it's look, I find it quite exciting, even if the others don't.
It's on something very interesting, which is the radio and the waveforms. We are actually, that's one of the reasons, even right now, the platform we are flying, we have a radio bridge on it. Not just the plug and play capability of multiple radios coming in and out, but we actually create a bridge that allows for multiple different radio types to connect into us and for us to then further connect them to other disparate systems in terms of radios. So we become that bridge, not the comms extension, so to speak.
Yeah, we're on a project right now demonstrating like a mesh network in the sky.
We really do listen to the customer and solve problems for the customer. It's, a lot of people try to push a certain technology down a customer's throat, and we're the exact opposite. We like to work with what they have. We like to find solutions for their problems. Like this, for example, taking different disparate radio systems and building a bridge between vendor A and vendor B so that there's disparate communications seamless because one of our aircraft is in the sky, while providing this on an enduring basis. This is all key.
I think the problem I've got is the name SOAR, because how much of the time are you actually under power and how much are you not under power? When I think RG-SOAR, I think, gliding. But obviously power is an essential part of the whole system. You've got to have power and you're under power a lot of the time. Wouldn't it be better to call it RG extended flight or something? Because you've got the solar and everything. I think it just paints the wrong picture in my mind. I'm expecting to see this thing finding thermals and tracing the thermals and mesh networking with other craft in the same area to say, here comes a thermal at this location. If you want more altitude, come over here by me.
I see what you mean. Yeah, so naming is. I should say marketing is a weakness of ArduPilot. we're not famous for that, for sure.
Right.
I'll put my ArduPilot hat on for a second here. So ArduSOAR is actually doesn't necessarily exist. It's a feature built into ArduPilot, and so some people like to say ArduPlane, ArduCopter. It's really the ArduPilot autopilot, and then you can make it. You configure it for the.
By the way, Bruce, we don't have ArduSOAR on quads. Multi-rotors, only on planes. So don't get excited.
I used to fly it. Anyway, that's another side.
But hey, Luis, pull request welcome, right?
Yeah, I know, Tom. I know. Something that it was not clear. So a system like this needs some very specific ground systems to support them.
No.
No.
It's ArduPilot at the core, so it can do everything ArduPilot can do as far as that goes. One thing that I'm adding to it, that I'm in progress working on, is something that I'll be adding into ArduPilot is getting native Ethernet connectivity to ArduPilot itself. So
I know of that one, but I'm speaking only on the ground control station because from what I know, the specificities of some of these systems would be way beyond what, for instance, Mission Planner can offer, and even perhaps Q ground control.
No,
well,
that's not true.
Why don't you add? Because one of the key things when I said earlier, operational efficiency is key, and having a small footprint, whether that be an Android-based tablet that gets integrated into the vest, or when we talk about open architecture and open connectivity, one of the things that we want to do is provide all of the connections software-based, right? So I can connect into whatever current ground control station that they might want to be using, or a tablet, Android or Linux or whatever tablet, and have a connectivity built back into it, versus pushing something down the customer's throat and having a large footprint. Also, we don't want trained pilots. I just want very simple operations. Everything is fully autonomous, and you put somebody who is not a pilot. I have flown these things, right? I mean, that kind of a thing. So, Sam, I don't know if you want to add anything to that, because that's a very relevant.
Just to echo it, it really doesn't require any kind of active management. It's very much an automatic system. It's like any other ArduPilot based vehicle. You plan out your mission. You put it into the arming or the launch position. You arm it, and off it goes. And then if it hits a failsafe during its mission, or you decide to tell it to come back, then it will do an automatic landing. And happy days, that's you done. So so it's really designed to be used by non-experts. So we can sell to our customers with minimal training. They don't need to be experts in how the system works. And the soaring capability is built in and integrated into the system, again in quite an automated manner, so that the people using it don't necessarily need to know the details of what it happens to be doing when it's flying funny circles up there in the sky. It's just up there busy extending the endurance of the mission and extending their capabilities.
Yeah, and keep in mind too, this is a Mavlink-based vehicle, so we're not limited by Q ground control or Mission Planner or any of those sort of things. So we can make whatever we want on the ground station, and many companies that do ArduPilot do that as a I should say that Mission Planner is basically like all the tools in one box, and that's great for like an engineering tool or to get going, but it's sort of too many options if you just want to go fly somewhere and do something more basic.
I'm not speaking of Mav Proxy, Tom. That's another animal.
No. I'm sorry. Did I say Mav Proxy? I meant Mavlink. It's a Mavlink-based vehicle. So I meant.
Yeah.
So it's on the ground. You can do whatever GCS you want from scratch or a modification of those. All you need to do is relay what you want to the customer or to the pilot to do some sort of task, and all this can actually even be aggregated over the internet as well too. I mean, on ground station stuff can be loaded up.
There's a good question there. What happens in the loss of GPS? Because it allows me to pull in the fact that I believe you've got machine vision on board, and that and not only is that on board, but that's separate to the payload of your. That's why I think. Just correct me if I got this wrong. Yeah. But that's separate to the payload of your current platform, which is a 7-pound payload. But you have all clever bits on board. So I'm just going to guess. Well, let's see what happens in the loss of GPS. Is anything sorted out for that yet?
Totally sorted out for that. And so, Steph and Tom, do you guys want to talk about various ways of the GPS denied environments that we're,
Sure. I'll let Sam and Tom talk about this. But the cool thing is we recently did some aerial demonstrations where we deliberately disabled GPS on the autopilot. And between Tom and Sam, do you guys want to describe what we did and our successes on that front?
Yeah, I can probably talk a little bit. We take turns on that. So yeah, basically in ArduPilot, you can disable the GPS during flight. And I modified that a little bit more to be more robust about the system to kind of prove it's off. And while we're flying around, we flew for about 20 minutes or so, 30. It's quite a bit of time, but basically we
I think it's
had
about 20 minutes. Yeah, about 20 minutes.
Yeah, and just doing a basic mission in auto mode the whole time and flipping it on and off. But the longest time we had it off was 20 minutes, and we essentially had about a linear drift of about 1 meter per second. We're competing against a lot of aircraft too that don't have any ability at all to data reckon. You turn off GPS and it literally just falls out of the sky. So it's amazing the work that Paul Rosenberg and the other ArduPilot folks have done on the dead reckoning and just the stability of ArduPilot to really be very robust we're into. And I want to add, I did a little experiment with this too. Just to see how far I could take it. I had my Skywalker X8 sitting on the ground. I turned the GPS on, let it sit there for a few minutes. It was all ready to launch. And then I turned the GPS off. And then I picked it up and I did a bungee launch. And it flew around for about 5 minutes and then did all autonomous, all in auto mode. And did the auto launch, cruise around auto, come down, did an auto landing, all with the GPS turned off. So it does drift over time. And it seems very linear per time, but it totally just works and it just kind of drifts. So it doesn't it's not square root or anything. It's not exponential. And I was able to do full operations 100% autonomous, 100% no GPS while in auto.
And the great thing is because it's
also. Sorry, Stefan. That also requires some high-grade flight controllers, right? From the enormous list of what we support on ArduPilot.
So we use the Cube Orange right now in our aircraft. My particular test was actually on a Pixhawk 1.
Yeah.
And Sam, you were
so it would get even better.
Yeah, I was just going to say that. The fact that it's a linear drift with time, and it's quite a slow drift. It's very manageable. Means that the inertial navigation is a really good baseline as we start to add the visual based positioning systems, which essentially just act as a correction on top of that. So we've got a baseline drift of as Tom says, around 1 meter per second, so about 3.6 kilometers per hour. And all we need to do is use our visual recognition systems to look for landmarks. And even if we can just pick up a landmark every 5 or 10 minutes, that's enough to just start correcting that position drift and lock us back into an absolute reference frame.
Yeah,
because we have to definitely plan, and one of the reasons why we're kind of accounting for a lot of these things is these are requests that we do get from our customers in contested or GPS denied environments. So for us, it's not just about, hey, it'd be fun to fly without GPS. It probably becomes almost mandatory for us to be able to support some of these things. And there are, earlier when we were talking about endurance, we didn't bring up the perpetual platform that we're actually going to be planning to fly before the end of the year, which is way longer endurance and which will.
Yeah. So on perpetual, really what we've done is we've taken everything we've learned from our current platform, which, because it was kind of the first really one that we did properly, has some compromises in it, some things which aren't fantastic for what we're doing. But we've done a lot of flight testing, a lot of characterization on the aircraft, on the solar panels, the batteries, and the soaring. And we're using all that information to design essentially Mark II, which we're calling the K1000 Perpetual. And the reason it's called that is because it's designed really from the start. The requirement was to be able to fly for multiple days and without landing. And that's through packing a lot of solar panels on it, very efficient solar panels, achieving high fraction of the mass being lithium-ion batteries, with good aerodynamics and the soaring there as well. So we're very excited to fly that in a few months' time. So the molds are actually being produced right now. So they'll be ready in a few weeks' time, and we'll start seeing prototypes that we can flight test.
And Gary, that's being announced first time on your
like. Hey, you hit it first.
You're first.
Hey.
Yeah, so it's literally
even though I'm the only believer here.
It's literally a from scratch development that we're doing, learning from the current platform, making our next generation platform even better.
How did I get bundled in this non-believer side of it? Hold on a minute.
You're not,
I don't recall any of
well,
this.
you've been very quiet.
I'm intently listening, is what I'm doing.
Oh, all right then. And I don't think Mark is either.
We are among gods, so all you can do is take.
Ian is learning. Ian is learning. He's learning about soaring. So
Yeah, I haven't played with that yet.
Next thing he's going to do a soaring chair.
Yeah.
Well,
Yeah,
if anybody's if anyone's using a reasonably recent version of RGplane in their aircraft, they actually have soaring available. They just need to turn it on. So so it's there. You have it in your planes.
Like I got a Bix list.
I know, Sam, but the planes I have don't like soaring that much because
you know what?
You should come to Arizona. Strong thermals in Arizona.
Yeah. So the best thing about soaring, the soaring module in ArcherPilot is it really doesn't actually care what kind of aircraft you do. All it cares about is if you have lift when you're not expecting it. So it actually it can detect the vertical lift, and then it'll go back and try to loiter around it, and then also track it as it moves as you loiter around it. So obviously, if you have a much better glide ratio, then it'll take advantage of it better. But any aircraft can take advantage of it any time.
How does a Bixler behave?
Fine.
Haven't tried it.
Fine. Well, I had the Mondo big one, the 2.6 meter one, and that worked. Really worked fine. And Tom 8 years ago sent me via Patrick sent me one of the 3DR Skywalker high wing, whatever they called it, things. And Sam very kindly helped me set it up again. That was in this very Pixel, and I had that soaring here, and it was fine. Not as good as a high performance glider would be, but it worked.
Well, I'm gonna have to tear out this currently. It's got an Eagle Tree Vector in it at the moment, so that's going to come out, and I'm going to jam a Hawk in and take it for a spin, I think.
Jam a Hawk in it.
And Gary, I think
if you see me build a craft, jam is really a good term.
Yeah.
Gary,
I've got to get the other one out because it was in two halves when I put it in, and it's one of those things at the time where you go, yeah, I'll never need to take that out. Don't worry about it. Yeah, it's got to come out now.
We have some. I know that on the internet there's been some screenshots, and then Gary's been done this a bit, where you can see Archer soaring, kind of traveling somewhere and soars up and does his little maps. But we have a link here that we can show you. We can do a screen share on Sam's screen, demonstrating just a square mission that we did, similar to the one we did the high altitude, where it's really taking advantage of the soaring. When we did the high altitude flight, we actually did not do any soaring at all. It was pure motor the whole time, motor and solar.
All right, let's see if I can pull that. Oh no, that's a 20,000 feet. I'm just looking. Is it in the links that you've put in the side?
Yes.
It's over there. Yeah. Okay.
I'm going to try this. I've got a client who wants me to do some flying at in a flight restriction zone. I might see if they'll let me go a bit higher. And I've got an Optera. I might have to try the soaring. I might have to try it.
Well, soaring doesn't make you higher; it just makes you go up for free, right?
But Tom, remind me something. Tom and Sam, we don't have vertical or horizontal fencing yet, right?
Vertical fencing, I don't think so.
You can set you can set a minimum maximum altitude.
Yeah, I take that back. And not part of the fence though, right? I think that's part of soaring.
No, it is part of the fence as well.
Okay, all right.
Yeah.
I know that there's minimum. I know that for sure there's minimum stuff.
So there's two levels of protection. Yeah. So soaring has a configurable maximum altitude that it'll actually thermal up to, but that won't stop it getting pulled even higher if your mission is still inside of the thermal. So then there's also the geofence, which will bring you back if you breach that.
No, I'm just thinking about what flight regulators would say if we would submit a flight plan that you say, well, usually fly at 350 feet, but we could go as high as 600 feet, so they wouldn't like that.
No. I want to correct that and what Sam said, right? So we've actually worked with some of the restricted airspaces as well as FAA. We can create geofence both from altitude perspective, as well as geofence and how far we can travel, and how, because we have to maintain in certain corridors and we can't surpass those corridors. So we've actually, all of our flights, we've had to designate those corridors and ensure that we don't go higher or we don't go further than what has already been defined. So that all of our flights are characterized by that.
But further, also, if, for example, you have a flight plan at a certain altitude, then you obviously won't be soaring because that'll break you out of the altitude. So therefore, we, in that particular case, we use just a normal thrust and our floatable takes on the aircraft to generate energy, and that's how we go for that particular operation. So it depends on the customer requirement, really. If they give us a lot of space to play with, fantastic. There's a time and a place for that, and there's a time and a place for straight and level.
And that's one of the reasons why when we were talking about the wildfires, right, we actually are a perfect platform to be able to do wildfire tracking, even just a trigger, and be able to fly long endurance perpetually in a very cost-effective manner to be able to do that. So we are a perfect platform when it comes to disaster recovery, wildfires, austere conditions, and being able to fly and forget almost, and then define a corridor you don't want it to exceed. And then we have ADS-B integrated on it, so it actually does the detect other aircraft, and truly coming in from urban airspace deconfliction. We really have thought through a lot of layers around that.
In fact, Fatima, it's a very important point I'd like Tom to quickly discuss, because in RG pilots, we typically, well, you guys are familiar with it, but UAVonics, we've just added support now for SageTech, which I don't think is an upstream yet. But Tom, do you want to quickly just describe the work we've been doing with a SageTech transponder?
Sure, yeah. So SageTech for ADS-B, they have some all the high-end type ADS-B out and in units. All their lower-end ones are all input only, but only the basically the most expensive one does. I'm sorry, most of them are all out, but the most expensive one does in also, which is kind of the opposite of what UAVonics does. But yeah, I wrote all the drivers for UAVonics back in the day for ADS-B. That's all in the RG palette and modeling spec, and I'm doing the same thing for SageTech. And it also turns out that the higher end models of UAVonics use the SageTech driver, which is kind of interesting. So it gives you the ability to set your squawk and whatever, all your settings, and turn it on and off while you're flying around, just via parameters in RG palette. So
yeah, and this is very, very important for integrating into the airspace safely, because then ground can see your current altitude, position, other aircraft, and this is what we're trying to do, is create a safe environment to operate in a responsible fashion.
Yeah, and what I have on the screen right now is our flight of our 12-hour day, and we were soaring on this one. And this, no, I'm sorry, this is a different day. This is not the 12-hour day. This is one of our it's an example of soaring. So we're just doing, if you look right down the middle of it here, you'll see that it's, if I can get it right, it's just a rectangle mission. It's 4 points and a do jump, right? But in our mission, we have it so that it's flexible on that, and it allows us to kind of go off course a bit and get airspeed, or I'm sorry, get altitude by seeking these thermals. So as it, I can run ahead here, while it's going forward, you'll see that it actually finds a thermal and then will go back to find it. It'll detect it. And so this is a nice little demo of it.
And then, of course, when it goes back, it generally doesn't manage to get right into the core of the thermal. So it's usually half in, half out, or just on the edge of it. Then there's maths in there to look at where the lift is good and where it's not so good. Now, Azure has an internal estimated model of the thermal distribution and shape, and it will compare that to what it's sensing and correct its internal belief about where the thermal is. So that allows it to recenter on the thermal in gliding terminology, and get into the maximum strength lift part of the thermal.
Here's a good example here on the screen on the left. You can see that as it went down, it's circled, and then as it went up, it was detecting that it was scooting over time. So it actually was recentering itself as it went up, and then it topped out at some point and realized that it's not there, and then continued on.
Okay, here's an important thing. With all that, I mean, this is all technically great and wonderful, but we all know that BVLOS is not allowed except under very important conditions. And if you're flying up at these altitudes, how are you deconflicting the airspace? If you're in a thermal, who's to say there's not a manned glider in the thermal with you? How do you know he's there? And what do you do to avoid hitting him?
That's a very good question. I mean, that's also one of the important reasons why we did integrate an ADS-B transponder onto the aircraft. But certainly, every place that we do fly, I just want to be very clear about this. We have permission to do so, and we have the altitude range to actually take advantage of this to be able to do it. It's all in restricted airspace. So I wouldn't recommend anyone out there to just go and climb as high as they can. They'll break some rules and they could hurt some people. So that's just a very important takeaway.
And I think
as a commercial service, if you're going to offer this as a commercial service, how are you going to get around that problem? Because I know for a fact that we have NOTAMs advising aircraft not to go in a certain area, and aircraft still go in there because it's only a notice. It's not it doesn't stop aircraft from going in there. So does this software have the ability to work with ADS-B in and automatically avoid approaching aircraft?
So avoid, sense and avoid, and truly the ADS-B, we had integrated ADS-B long back, and now, as Tom was mentioning, the Sage Tech integration as well. So ADS-B has been a key component of how we've operated specifically because of that. Airspace deconfliction is part of how we look at things and how we operationalize it. We're not building anything just for the sake of lab. We're building everything with actual applicability in the real world, and the airspace deconfliction is a key part. Most of the use cases that we discussed earlier, they're all dense, urban, populated areas and countries. And that's why the airspace deconfliction becomes even more serious. We're actually even working with Deloitte and looking to partner with them because they have the project from NASA as well as FAA to talk about urban mobility and urban air mobility and deconfliction. So we definitely have a seat at the table there to kind of make sure we're aware of what's happening, how the regulations are changing for the next generation of aircraft, and how ADS-B and other components kind of play in to ensure the safety of everything we're doing.
And further from that, you also can configure ArduPilot to take certain actions when a potential collision, and that's also definable what that means, does become a reality. So, either do an under-over decision. If you're in a multi-rotor, you can take different types of actions. So it's very definable.
Yeah, and that's all part of ArduPilot
now, Bruce. That's in ArduPilot now, Bruce. That's not a particularly new thing anymore.
That's right.
Does this work with FLARM and UAT as well?
Yes. Actually, well, there's no FLARM on ADS-B, but FLARM, basically what it is it can look at it can gather information about a database of other vehicles from a variety of different sources. So in fact, that's kind of how the follow system works in ArduPilot, where we're avoiding someone, but we're also trying to hit them at the same time by going at them and kind of keep on them. Steady. Yeah, so it kind of goes hand in hand. But basically, it keeps a database of all the vehicles, and that goes into the avoidance library where it uses those as targets. And the avoidance library can take targets from ADS-B, or it can take it from any MAVLink on the same network. So if the vehicle is actually seeing heartbeats or whatever information from other vehicles on 900 megahertz or whatever radios you have, if it's getting those messages, it adds it to the list and it knows where they're at.
It's quite impressive, really, that when you think about it. First of all, that Ardusour's, there's no companion here. This is all part of ArduPilot in itself. When you look at this additional functionality, you'd be forgiven for expecting there to be a companion or something in there running this code. You mentioned, Tom, earlier something about Ethernet support that piqued my interest a little bit. Coming back, is it something you can explain a little bit more about?
Yeah, so I'm adding Ethernet. I've mentioned a few times on the ArduPilot developer call, weekly call.
It's a bit late for me. It's normally about 1 a.m. It's the same as Louis, unfortunately. Me and Louis have that.
No.
I'm in the same boat. I'm in the same boat.
You're in the same boat.
Yeah. Luckily, there's a Wednesday morning call as well. There's an EU dev call now on Wednesday morning.
I did see that.
It's much better.
That's a new thing. That's should get more of you on this side of the planet involved in. So that's really nice. But I was not there. I was not mentioning this on that call. I was mentioning on the normal call. Anyhow, Ethernet is we're adding it right into the STM32 that's flying. Okay. So it'll actually be running an IP stack, and it'll give you all the normal TCP, UDP, FTP, HTML, whatever serving you want to do, as long as it fits in the program memory, or if there's any offload memory, it'll handle it right there. Right now, with all the STM32 like F7 stuff, the ArduPilot is like idle a lot of times, right? Or I'm sorry, the chip is idle a lot of times. It's those chips are super overpowered. So even with the high-end F7s, we can load web servers and FTP servers and host stuff, and it's like no big deal. The idea is it'll eliminate all your well, it shouldn't eliminate. It's still gonna have serial ports, but it'll give you the option to have 65,000 or whatever serial ports. It'll give you the capacity to talk to multiple devices in your system. So talking from your autopilot to your NVIDIA or whatever companion computer, now it's Ethernet. Now it's a proper system that you can talk super high speed. There's no more param downloads. It's all instant. There's been a lot of work on there to get parameters and missions via what we call MAV FTP, which is kind of like put them all together as a package, and they go a lot faster. Before it was kind of like send one, verify one. It was really slow, and so now it's just like it happens a lot faster.
It's been a game of if you wanted it, you either had to do it via your radio system, or you were having to do it converting to MAVLink. The companion had to run MAV proxy or whatever just to be able to get communications.
And so now radios themselves have Ethernet right in them. The microhards or Sylvis, there's other ones out there. So you get your 1, 10, 100, whatever megabit link to the ground to send your video, but also your autopilots on the same system. It's all one link this way. And then you can also have things like your autopilot can talk NMEA to your gimbal or whatever ground station, and it can talk to 10 different things at once, and you're not limited by serial ports to talk this and that. So the Ethernet will basically act as if it's a serial port inside. There'll likely be, right now there's a thing called serial manager. There'll probably be an Ethernet manager. This part's not done yet. I'm working on getting the Ethernet actually partnered into the Chibias system. So it'll be using lightweight IP, LWIP, and getting that up and going. So I have a developer kit. So I'll be doing all the work on that. I'll have my hands full.
Guys, there's one more thing I want to talk about on the show, which I think is a fantastic contribution to the community from Carl Zanzani Aerospace, where we're going to save a lot of people, a lot of money, and a lot of airplanes. So one thing which we have consistent tested, trialed, and implemented is an anti-spill feature that will save you. So Tom, do you want to maybe just talk about that? I think that is very cool.
So one of the things, in fact, if I can go back to our high altitude flights, let's see, where is that? We actually have a stall on there I could show you.
And just while you're looking for that, Stephen's asking, does Soaring require a static pitot system to detect lift? Now, I know the answer, but perhaps one of you grown-ups could give the proper answer.
That's on SAML stuff.
Yeah, so Soaring doesn't require any special sensors. It does work best with a normal pitot airspeed sensor. It doesn't require anything else on top of that. It uses the standard barometer and accelerometers on board any autopilot chip.
There we go. Thank you very much. And I want to say, I must have been like 4 years. I've been trying to find my picture of mine going round and round. It must be at least 4 years ago, and it is to all intents and purposes magic.
It was about 2013, I think, when you were doing testing for me, Gary. So you've been involved for a long time. Yeah.
Gary, are you sure it's
I'm not that
still
old.
not soaring?
I'm not that old.
Come on.
Sorry,
Gary,
he's still in short pants.
I think it's still soaring. Have you looked up? If it's not there soaring around.
Well, actually, that does beg another question, really. So, you're saying it's a persistent system, but how on earth do you make the airframe persistent? Because it's out in that UV all day long. I mean, that's a different kettle of ball games altogether, isn't it?
Suntan on the airframe, so the problem solved.
A sun cream, of course. So, yeah, of course. That's simple answers.
You'd be scraping that off at the end, won't you?
It's not made of foam, put it that way.
No.
That's a very, very good, I think, answer, Steph. But, yeah.
Not made of foam. Tom, can you bring up your screen with that store? I really want to show that to everyone.
So I'm showing this right now. This is actually us flying.
Hang on. Where is it? Hang on. Okay, I can add it there. Hang on. Here it comes. There it is.
All right, so here is the stall. So here's one of our stalls on our high altitude flight we did a week ago. I'll back it up here. I'll zoom in a bit. So here it is. We were, for efficiency purposes, we like to fly real slow. right? That's the idea. We can go. We have the flight envelope to go really slow and really fast. So if you want to be efficient, we just try and go slow. So I've created this whole stall detection and stall recovery mechanism for ArduPilot, which I'll be committing some pull requests here pretty soon to put into for everyone to get. And here's an example of it where we try to slip it down a little bit, and then once it stalls, we kind of slip it back up. But here is, I'll do it in real time here. So here it is in line going towards that waypoint in that square. And then it climbed up and it basically stalled out at some point. Maybe I'll go a little faster. 2 times speed. So it's
maybe move the screen to the side if you can.
Do the what? There. So it actually stalled. It stalled and kind of figured itself out. It rolled to the left, it looks like, and then it pulled out of it and it just came on back. So this was purely stall detected and then automatically recovered, and we lost a total of 100 feet on that.
Wow.
And that was we look over and we say, oh, it just told us it stalled and recovered and just kept going. We didn't even we weren't involved. It just did it. And
yeah, it's really crucial technology when we're doing very long flights, quite close to stall speed.
Yep, and there it is again. So we did 2 stalls here back to back before we said, oh, we should probably raise this airspeed up a bit.
And then, so that doesn't happen automatically. You just knock up the speed on the ground control station.
There's an option to automatically bump it up by like 0.5 meters per second if it happens twice. These are things that we'll probably negotiate and figure out on the way upstream wants it. But it'll basically, if it stalls once, no big deal. But if it stalls again in a certain time, I think it's like within 5 minutes or something like that. If it stalls again, it'll like bump up the airspeed a little bit, and then it'll just repeat. It'll just keep going up if you keep stalling.
But flying that close to the stall isn't going to be the most efficient, is it? Because you've got the lift drag rate curve doesn't look very good near the stall. So do you have different modes where you go maximum range, maximum flight time, well, whatever? Have you got those modes automatically built in, or you can set them?
We're making those profiles up right now, but right now we're doing them all manually. But the idea is certain things are better at slow, some things are a little bit better fast. Also, it's very gusty where we're at. So even though we're not like at the stall speed, we're up above, sometimes we'll like some really crazy gust winds. So since we're below what we'd normally be at, we're more susceptible to those, which is typical for any aircraft. But
yeah, you're right, Bruce. If you want to get somewhere, then we're operating a bit faster to get the max L/D. But for these long endurance flights, we're down at minimum sync speed, which is pretty close to stall.
Yeah, and here's our high altitude flight. We were at 20,000 feet, and it was just this big square or this big rectangle, and we hit 20, and then we were going up and down just to make sure we had enough power. Our clearance at this airfield was 20,000 feet, so we weren't really allowed. This is actually 20,000. The airspeed says the AGL. Yeah, so on here it's off by 850 feet. So actually, it looks like we breached it by 29 feet. Sorry. Anyways, we're at that top level there. And one thing I wanted to note here, which was pretty amazing, is we went in the middle and did some tests, and we're coming down to loiter down. And this is actually quite impressive. We were looking at just coming down at different rates, and we were coming down slow. And this is just super impressive here, right towards the end. We're going down relatively slowly, but then we decided to go really fast. And what's hard to explain there, or what's hard to show, which I'll pause it here. Our climb rate is down here at 1,500 feet per second down.
Per minute.
Per minute, I'm sorry, yeah, per minute.
Yeah, second.
Yeah, so it's going. It's going
so
anywhere
with
from
this aircraft. Yeah, so we're talking about how we control that descent rate. So on this aircraft, we have a lot of control surfaces. So we can actually have a lot of control over the configuration of the aircraft. So it actually has 6 control surfaces on the wing, and then your dual elevators for redundancy and the rudder. So those 6 control surfaces on the wing allow us to change the whole camber of the wing, so we can make it more flappy or flatter as we need to, depending on what airspeed we're operating at. But we can also deflect them in a kind of air brake type configuration where we put some of them right down, some of them right up, and that allows us to Yeah, right. Yeah, we do crow. So that allows us to really reduce the lift to drag ratio of the glider a huge amount, add a lot of drag to it, and come down very quickly, but without overspeeding the aircraft.
And so that's all part of Tom's Autoland, is it? Because Tom is the man that wrote. I think you pretty much did all the Autoland stuff, didn't you, Tom?
I spent a lot of time improving it. Yeah, so I mean, Autoland was one of the first things. I shouldn't say first thing, but it's been there for a long time in some crude manner, and I've improved it a bit, so it's less crude. It's better. It's pretty good. I mean, it lands our vehicle, which is a decent vehicle to be.
So what's the mission going to look like then? We're talking about saving money and all that, less people. So we've bought one of these things, and Lou and I are going to operate it. We've decided the regulators discuss with us how it's going to work, because surely someone's got to be on shift. Our flight time limitations are going to come in, so there'd actually have to be 3 of us because we couldn't do more than 8 hours. So they're operating it. Well, would we just someone would be overseeing it, but then all the data that's coming downhill from it, are we bothering with that, or is that shipping off to somewhere else that's going to look after that data? Are we, Louis and I, just going to monitor it where other people crunch the data? That's what I'm getting at.
Yep.
Depends what you're trying to do. I mean, the nice thing now is that the people doing that data crunching don't need to be on site with you guys in the field. So even on some of our recent testing, I'm in Scotland. I couldn't be in the United States for the recent tests in Arizona. But I was able to access all of the data from the aircraft over the radio link, and then hopped over the internet to me. So now it really allows you to distribute your operations. So yeah, you could have analysts situated remotely looking at that data, no problem.
That is something that is easily done. For instance, using MAV proxy, you just put MAV proxy acting as a relay, and then you can remotely operate and monitor whatever vehicle runs autopilot.
Yeah, but as soon as autopilot has Ethernet, then you won't need MAV proxy.
Then a whole slew of new problems will come up, Tom. That.
So you don't need MAV proxy for that, I should say.
So how long before someone's going to willingly accept we're going to have to put the nail in the coffin of some older boards? Because I think it's going to happen at some point, isn't it? That, obviously as everything's expanding, there's more and more going on.
Alex said right now, Alex, pass me the hammer.
Who's going to try and get it past Tridge?
Yeah.
So to get back to your question about applications for it, if you have the ability to do long-term being on station and kind of loaded where you're at, for a long time, that has its purpose for communications, for relays, for cameras, for all that sort of stuff, where no one really needs to worry about where the aircraft is as much as the data that's coming down, right? So you're saying that someone's watching the aircraft, but maybe they're watching other aircraft, they're watching lots of them. But also because this is mobile, could be perpetual or infinitely in this airspace. Think of applications where you're doing some sort of thing in the west coast or the east coast of the U.S., and then suddenly a hurricane comes through, and it maybe not a hurricane, but earthquake or something. But you have to go down to like Costa Rica or Puerto Rico. I'm sorry, Puerto Rico, and we're in the air, and it's just a matter of getting over there. Then, right? We can just say, we have a spot. Go over there, and then now we can we have electronics that can be on board. Given the different payloads, you can be an LTE antenna, or you can just be a camera monitoring changes of water, rescue and all that. But the idea, you can be there almost immediately, right? Or I should say immediately, but a lot faster than shipping an aircraft over there to fly it. It's in there. It might not be the fastest thing, but it'll get there in 24 hours or so, and it's just kind of it'll just kind of chug along.
And if it's above 60,000 feet, it's above the weather and all that sort of thing. So you're up and out the way, and I completely get it. But then your actual crew. Now I know Fatima's going to say we don't want people to be trained. We just don't care. We just want to chuck them in the air. But that means if you're just poking you with a stick. But that means, to have a crew that's able to operate anywhere, let's say within the bounds of the US, their aviation knowledge would be quite high. And as we mentioned in the live thing, now, of course, this is part of the fight for. We're at this weird time in life where there's a fight for airspace below 2,000 feet and a fight for airspace above 66,000 feet. Traditionally, spaces that nobody cared about. They didn't give a hoot about those spaces, but now they do. So, yeah, I suppose you could just have a single ticket for not below 66,000 feet, go where you like. But you'd need quite a skill set in your crew. That's a very long-winded way of saying that, wouldn't it?
So, Gary, here's the other aspect of this, right? I mean, there are a couple of things when we talk about human-machine teaming and the ability from the beginning, if you're thinking about where you're eventually going, even right now, I can do active-active handoff, right? So I can have multiple different crew monitoring and being able to control the aircraft and say, hey, this is mine now, and hand it off. And, and so if we are under contract, we know there are susceptible disaster zones where you might need the aircraft, and we have teams there that can do active-active handoff. Simultaneously, eventually, we'll also want to be doing swarming between aircraft. So there is communication that's happening between the aircraft. Right now, we're doing that through the ground control station, but eventually swarming that's happening between that. And that's where, so we're not just planning for today, but we're future-proofing for tomorrow and where tomorrow is going to go. That's why I don't want to get into the fight of space and let the space fight go on with folks who are fighting over space and maybe lower altitude. If I can truly come and supplement stuff at the higher altitudes and complement other assets that are flying within that to actually extend what they're doing and eventually what we're doing as well in that whole stratosphere layer, even from a backhaul of data.
Right? So what we are saying is Elon Musk cloud is here and you'll have your cloud here, right?
Hey,
we're actually considered we could be considered a pseudo satellite.
Yeah.
At those altitudes with perpetual flight, the first thing that comes to mind is why should we settle with the drones or satellites, call it whatever you want, of Elon Musk here, if we can have more efficient here?
I think Gary, we have a converted crew here who's now
maybe.
Keep in mind too, the VTOL thing is nice because you need to take off and land, but sometimes you just don't need to land, right?
Yeah, exactly. That's why. We were having this very discussion today here about a baby shark versus the believers, which we're big fans of here. You could just fly in to the site from a lot further away. There's no need for this VTOL nonsense. It is nonsense. You can always find somewhere to take off and land. Perhaps that requires very good glasses. Very good glasses for tell that to guys. Yeah, but they're called helicopters if they're low level and doing their things. And mind the that story for the Royal Navy's gone nuts. What's he done? Oh, there's a believer there. Yes, that does 99% of anything anyone would want to do. And it allows you, because of its range, to select a really good place to take off and land that's safe and secure. And as long as you have 80-kilometer eyes, you're perfect. You're good to go. Because that's the only limitation.
That guy there is the guy that flies on his backyard, so he does not need 80 kilometers.
Yeah, no, that guy. You're pointing into mad then, unless things are different. So
it's the other one.
Yeah, one over. I think personally, it's very, very exciting, and thank you very much for telling us about your new platform. And I hope we're going to hear lots and lots more about this and be able to keep up with it. Be very interesting. Will you be live casting? Do you think that persistent flight before the end of the year? We'll be able to get into that. Do you think?
I think everything that is what we were alluding to. I'm hoping you'll get into that. We'll need a lot of popcorn if we.
Oh yeah, that's true. Oh yeah, I hadn't thought that through. What you're showing us here, Tom, is this a stall?
Yeah, so this is the stall that I was showing earlier, and here's an example of we're flying along, we're pitched up a little bit, and then the actual roll just diverges, right? You drop a wing, we go down to 55 degrees on one of the wings, and so we do our hard pull, and then it kind of freaks out, and it automatically switches into mode 25. So this is actually a flight mode right now for stall prevention.
Oh,
or stall recovery. Yeah, so right now it doesn't know what this is yet. Mission Planner doesn't know what it is yet. So it will soon. Coming soon to an R2 pilot near you. So it fixes this, and then it basically, if you see here, it's actually holding the roll, and it's kind of it's doing the typical procedure where you would kind of do flight or level flight surfaces. It would so our particular aircraft, if you just hold everything neutral, as if you flip the manual and just do hands off, you'll kind of steady state yourself back, and different platforms like throttle, other ones don't. Sometimes you want to pitch down a little bit, others don't. So on this one, we're actually everything level, and we let it kind of level off a little bit, and then we hold, and then it switches over to the equivalent of stabilized mode, where it's just trying to hold the horizon. And it does that for a couple seconds, and then it resumes what you're doing. All that's automated when you switch over to the stall recovery mode. The other thing is the stall detection. So I think if I say messages in here, it'll say, oops, stall detected. Yeah, you'll see. If I go full screen on this, you'll see at this point.
You don't want to have people, because especially at high altitude, you'll pull the wings off if you try and pull the nose up or whatever too abruptly. I can see people, if they have the ability to make this aggressive, pulling their wings off the aircraft if they're not careful. Just like
we have set to 6G on our side.
Yeah, so this isn't really designed. This is if you stall, which is a fairly easy thing to do if you on the autopilot. If you just set your cruise speed down to nothing or something, you'll see the characteristic of the stalls and for your given aircraft, and then so as it drooped and then it rolled, you see actually it flipped over, just we're stalling. It jumps in and says stall detected, and so it takes this much time to really figure it out. But altitude really didn't drop very much. And I think the total of this whole thing was, like I said, 100 feet or so. So that's not much to detect you have a stall and then actually pull out of it in your given way.
I already know the answer to it, but I'll let you or Samuel explain. Why didn't you go doing some Lua scriptings to detect this and act upon the vehicle with Lua scripting? I already know the answer, but I would like you to explain the thought process around that. Either you or Sam.
Sure, Sam, go for
it. So we did this before the Lua scripting was mature. So I believe this could possibly now be done in Lua scripting, but at the time it couldn't be.
Yeah. So 2020 is supposed to be the year of Lua scripting for R2 Pilot. There's lots of scripts going in, and so this is something that when I say I'll send it back up to upstream on R2 Pilot for the public to have. I think it's going to turn into a script essentially. But some of these things need to run are different on different aircraft, and the configuration is so difficult that it may not be a very good parameter type thing. That it really needs to be a Lua type thing.
Oh, you could just see people saying, "Where am I going to get 25 switches from a radio to so I can mode 25?" You can just.
Well, no, I mean auto is 10, I think, or maybe 11. But yeah, I mean it's just all different modes. That's why you select one.
No. That's why it's not what people do. You know, they want to have
Gary.
Go on,
Gary. Do you know why they didn't go for a VTOL? Because they have a lot more of flight modes on VTOL on planes.
That's true. There is a lot.
Yeah.
Yes, there are. It's amazing. Well, look, it's an hour and 18. This is fantastic. But please, guys, stay with us because we need to catch up with a few of the other news stories of this week. I'm jealous. Come, bring it. Come on, Stefan, bring it home. Bring it home. Bring it home to my house, and we can do some soaring here. And you can have some bunny chows and Mrs. Balls. Mrs. Balls won't make a lot of sense to a lot of international viewers, and it doesn't sound right. Mrs. Balls does not sound right.
I think what we should do is set up a petrol aircraft down to South Africa to go pick it up and send it back home. The site in the US.
Yeah. It's
But
probably
I don't see what's the problem, Gary. When they launch the Perpetual, they'll just do an out-of-flight from where they are to Durban. So why are you? It's soaring, so it should be easy to do.
So across ocean, actually one of the requirements for the Perpetual.
Yes,
it's in the requirements document.
Yeah,
it's not to South Africa, but from California to Hawaii is a requirement.
Well, that's against the jet stream, isn't it? You want to say rather Hawaii to California?
No, we can do both.
Or not, anyway.
And if air control gives us permission, we'd love to go around the world once.
Yeah. Well, there is that prize, isn't there?
Don't worry. You have lots of paperwork to do. You can start filling up the flight plans right now.
I bet you wouldn't. I bet you wouldn't at 660. I bet you wouldn't. I bet that would be quite easy at high altitude to sort out.
I agree. If we are flying, and that is the next level. The Perpetual that we're coming up right now will be lower and medium altitudes. Higher altitudes, when we're talking about the 65. That will, it will definitely be easier to do that.
We used to pull up a sandbag. Here comes a story. We used to talk to the SR-71 crews when they left the UK. But when I say we used to talk to them, we used to fight to talk to them. All we said was, whatever the call sign was, I don't think I'm at liberty to say, radar contact. And then we'd wait, and then they'd switch the transponder off when they went, because they wouldn't actually speak to us. All they'd do is they'd flash ident when we said contact identified, and then they'd switch their transponder off when they went above 660, and we'd say radar service terminated, and that was the whole thing. We used to fight. That's what we said to them. We used to fight for that. And the U2 guys, the TR1s, they came and gave us a talk. It's a long story, this, isn't it? But we used to have to give them avoiding traffic all the time. And they said, when they came and gave us a chat, they said, well, when we're up there, because of the cockpit size and they're orbiting over the UK, we can't actually see England because it's been obscured by the cockpit sides. So we're giving them avoiding action because they become a primary turn because it was secret at the altitude they're at. So they became
That's pretty bad situational awareness when you can't see a country.
Exactly. It is pretty bad, isn't it? But they said we can look all the way to Russia, but we can't actually see England. So it's like, you're quite right then.
We are a tiny island.
Yes, true. So there's not a lot up there, and Concorde's not around anymore. So it's you'd only Google Loon that you've got to get out of the way of, and they'd have your weather data. You'd have comms all the way around because they're there. God, it'd be easy. Be so easy. Be so simple. So easy.
Well, Elon will give you the communications. He's got his Starlink thing, whatever it is. That'll keep you in touch.
The backhaul to what he wants to do. So we will be the enabler. He won't be the enabler. I'm just kidding.
So, Bruce, you're not in prison. Tell us why you're not in prison, but somehow you've managed to get the rest of your country locked down again.
Yeah, I'm a bad person. No, I'm not in prison. We're still waiting for Mr. Winter to come back to us. I'm going to give him a week. Fair enough. He's a busy man. Give him a week to come back and tell me what he's going to do. And apart from that, it's been absolutely nothing. I've just been watching the professional drone pilots in the UK make a dog's breakfast of bringing back a matrice. And I've been working, of course, on this for the belt ADS-B alarm, which will...
Oh, I'm glad you said belt. It's a hell of a pocket size you said it was.
This is a prototype. There will be a smaller version, but this is just to write the software and get it going. And I'm picking up aircraft with this antenna, which is not tuned to not actually tuned to... not tuned to 1090. I'm actually getting aircraft up to 30 kilometers away, albeit they're at 17,000 feet. But certainly, and it's working really well. And I've added an extra feature. Previously, I had a distance zone, an intrusion zone, so when aircraft came within, say, 2 miles, it would alert you. Now I've got actually a time thing. So if an aircraft's within 3 minutes or 2 minutes, it will alert you, because different aircraft traveling at different speeds, that varies the distance, you see. So I've just been playing around with the software, getting that sorted, and it could be a valuable step forward in terms of safety for people operating drones and models in the public airspace.
Well, you see, UAVionics have just announced tonight a new thing. I can't remember what they call it, but something professional. But
Bruce, why do you want that? Because you're flying below 400 feet. There is no general aviation below 400 feet. Why are you getting worried with that?
But it logs all the craft passing through. So if you do have an incident, you've got the data there to say, this is the call sign, this is the altitude, this is the speed, this is the trajectory. We didn't do anything wrong. It's this bloody helicopter coming through at 200 feet that was the problem.
That smells like remote ID.
Yeah, but it's for manned aircraft, not for drones. That's where it should be.
Yeah.
So it'd be nice. It'd be nice if all aircraft had it, but there's pros and cons of that.
No, yeah, but I mean, until if the regulator is talking safety, then he who gains the benefit should carry the cost, and the benefit to being able to avoid drones is almost entirely in the manned aviation community. They've got a lot more to lose than drone operators, so they should be paying the cost of preserving their own safety. And if someone can't say, oh, these drones are a problem, if there is a simple way for them to be avoided by drones, and that is fit ADS-B to their craft, even though you may be operating in Class G.
Yeah, but not even all aircraft require it in the US.
No, same here. In Class G, you don't need it, but it should. Why don't you need it? If you're going to have a remote ID on a 251-gram toy, why can't you have ADS-B on a manned aircraft?
Yeah.
The problem is with it, you've got DJI have openly said every aircraft they manufacture now onwards will have ADS-B, or AirSense as they like to call it, but it's ADS-B. So potentially everything sold from now will have it. We will have 80% of the consumer drone market will have ADS-B.
That's input only.
Yes, but that's all that's important to you. But that input is important. Remote ID is all of the governments have said they don't want ADS-B on drones. Well, most of the major governments have said they don't want ADS-B involved.
I don't see why are we so concerned with all of this, because as we all know, the future will be for us to pay to fly. And when we pay to the airspace, we can fly in our own rented airspace. So I don't see the problem here.
My point was, we're going to have probably, we're going to have 80% of consumer aircraft sold now, plus with ADS-B in. We've got the Cube that has it now as part of it. We've got it, we have ADS-B falling out of our orifices, yet nothing has changed. It hasn't changed safety because manned aviation haven't actually out and out made it a requirement to go on everything. And whilst it's good that we're getting it, we've got the ping built into the Cube orange with the carrier board, we've got DJI who've made a step, but the reality is, unfortunately, unless manned aviation actually takes it seriously, it's lip service. And it's not lip service on the drone side. We've done our bit. The drone industry has done what it needed to do, yet they're the side letting it down now.
No, to play devil's advocate, it's a lot easier to receive it than to transmit it.
Yeah, not in this day and age. It is, but then again, look, we live in a world where you can put transmitters on anything. Yes, there are requirements. If you look, UAVionics have tried to make it as easy as they can with some of the options that they've put out there with the nav lights with it on and things like that. Yes, there is a cost involved, but when it comes to safety, everyone keeps saying cost doesn't come into it. So we either have to accept that ADS-B is the answer or it isn't, and we stop messing around with it, because that's the problem with ADS-B.
The other thing is that it is the responsibility of the unmanned aircraft operator to keep out of the way of aircraft, not vice versa. So we are the ones who need to be able to receive a signal they send, not vice versa.
Yeah. Look, at the end of the day, these guys are their fans. The technology they're working with, the Tom and Sam with the autonomous soaring and stuff. It's all the bits are there, and there's just the regulations aren't there for the persistent perpetual flights. All the bits are there for the hobby side of things to receive and get out of the way of stuff. But it's just I think this community is offering up many solutions to the manned world, and the manned world's not listening. I think is what I was trying to say, or it's not wanting to listen. Go on, Mark.
The biggest problem is regulation never keeps up with technology. That's the biggest problem.
But I think
that they can't keep up with everything. They just can't. They don't seem to grasp it. It's really bizarre. But regulation's always behind the technology, always.
Well, I think that's true, but I don't think there's an excuse so much now for this one, because how long's ADSB been in ArduPilot, Tom? 5 years? 4 years? A few years.
4 or 5.
Yeah.
4 or 5.
Well,
So
I note that I actually had all the alpha units of the ping back from Avionics before they were releasing anything. I actually worked with them very early on. And if you notice on their website, they have Pixhawk all over it. They're very supportive on that. So they're a really good person to work with.
So it's not like we're saying in 2020, hey, regulators, why don't we do this? We could do this. It's been done. And DJI Kiosk Prince mentioning the Best Buy flyer. Well, it's going to be in the new DJI gear is going to have as AirSense, I think, as you said, you call it, Ian. It's going to be there. So as the bigger group, why ADSB started longer ago than that? Kiosk, it's 1990s. But it's 30 years old, it is. That's why it's flipping crap.
Interestingly, interesting, I'm a glider pilot, and ADSB is not really used in gliders, but they use FLAM, and I don't believe it's compulsory, but it's very widely adopted in the UK, and I believe in other nations as well. On a voluntary basis, because it's been recognized that there's a very high safety benefit from using it. So maybe that's the way to approach it. But the fact is,
and that's really an air-to-air sort of thing. Where
it is. But also, glider pilots are very sensitive to cost. The operating costs of gliders are very low. So if it can be done effectively in gliders, I don't see why GA could do it.
And that's my argument.
That's my open glider network gear there, a whole $30 worth of OGN gear, which is because FLAM, that's one of those things where the protocol was hijacked a little bit by a commercial group, should we say. It's a bit of jiggery.
The problem is we've got so many standards now. You've got ADSB, you've got UAT, you've got FLAM. I mean, it's so you've got to be listening on so many frequencies with so many different protocols to actually make sure you're picking up everything that might be out there. It's becoming a bit of a dog's breakfast. It needs to go back to some unification. And fortunately, with a software-defined receiver, you can pick up all those things. But it just adds to the cost when you've got to do that.
Yeah, well, that was actually the goal of Google. They wanted to be an AirMap. They wanted to be the digital air traffic controller, where you're telling them over the internet where you are, and then they broadcast that to everyone else. And then there's another layer of approval to fly, yes or no, but at least you're aggregating where vehicles are at.
Yeah, and the problem is we've got about 4 different angles. Obviously, we've got remote ID creeping up on us around the corner, and more than anything, we've got governments telling us it's not about safety, it's about security. Let's not pretend it isn't. That even the UK government out and out said it was not about. The UK government actually said it wasn't about safety, it was about security. So we've got obviously the safety aspect, which the drone industry is trying to push, ADSB at the moment. We've got remote ID, which is really a tool for identifying something after the fact or as it's happened. It's more identification than anything else. Yes, it's being disguised in the whole BV loss, and it is a part of you can't do it without some form of identification, but the overall reason for pushing remote ID is security.
That wasn't really the remote ID push.
No, but that's what if you look at the UK government are pushing it as BV loss. We can't do BV loss without it. That they're sort of wrapping it up in this stuff, but the reality is it's security. It's absolute security.
Remote ID is just a pig's ear in the UK.
Pig's ear.
Trying to get anything out. Trying to get anything out of them on exactly what it is. And remember, remote ID. So you just have BV loss, but that'll be UTM systems. It won't be remote ID, because remote ID is allegedly a police officer can have a mobile device. It has to connect to the drone. So you see the drone, you look at it, it tells you who the operator ID is, how high it is, and a little map showing where it took off from and where they're stood, where it took off from or the remote pilot is. That's all remote ID does. It doesn't talk to anything else. And when you power down, that information is gone. It doesn't go anywhere. There's no need for it to be sent anywhere or do anything else. That's not in any part of its ruling. All it is a little widget that says, you're flying at this night and I'm here, my pilot's over there. And that's all it does. That's in the UK, that is.
Well, yeah, but that's the way the technology works. And it's also the same thing with ADSB, where you power it off and it doesn't have any memory or whatever, but yet there's online services where you can log that stuff for months and stuff.
That's the issue. As soon as someone starts recording all that data, here comes the privacy lawyers jumping up and down. Oh my God, where did we go? Why are we recording this, and why are we recording that? And then we open a new can of worms. But the gentleman here is used to open cans of worms. So
only those with something to hide have anything to fear.
I'm just so over that whole idea.
And that's why all our politicians have webcams in their bedrooms.
Yeah.
Hang on, I've got another one here. Hang on, this is another one that will work. Nobody saw. That's another thing. Nobody saw this coming. No, we've not discussed this at all, have we? Never, ever, ever.
Well, we're coming.
I think it might be good to note that I did the first remote ID flight.
Yeah.
I'm not sure you guys realize this, but I was when I was at Intel, I was doing all the we were pushing the spec, and I worked a lot.
You say the first flight, but it's not actually agreed that the American standards are going to be picked up by the rest of the world. The perceived American.
I know, but it was with the committee and stuff. But I was doing a lot of the work on the back end to make that work. And I did a prototype where we had the FAA actually. We were standing next to the FAA doing this test with them, and which is never fun because they're like, "Where's your checklist? Where's this and that?" And it's like, I got it. So they wanted to make sure that they weren't like judging anyone, but they were just want to see how the whole thing worked, because they come in from the aviation, they have like no idea about drones. So that's the thing. Yeah, so I outfitted some hardware, some Bluetooth hardware, and basically implemented the spec at the time, the preliminary spec, and flew around with that and demonstrated. And I made a little app on Android and for iOS.
There's a website with this listed on. I've seen this. Is it the web? There's a website Intel put up somewhere with all of this on.
So they made it open. We made OpenDroneID.org.
That was it. I've seen it before.
.org. I think that's what it is.
And it's weird because the whole thing's become a bit of a mess. Obviously, in the US, we've got to be hearing any time from the NPRM, Gary, because there's not been anything.
Oh yes,
it has to be.
Wasn't it near the end of the year they said or something?
Well, I'm sure it's due any time, and with all of the bad news going on around the world, it would be a good time to shove it out.
It doesn't take long to reach 60,000 submissions. That's for sure.
No, nothing else to do. They're not going into work, are they? So why not?
Obviously, the last thing we heard on the US side, they'd watered it down quite a lot when I read the documentation on the last one. Obviously, in the UK, as Mark said, we're following Europe, which is the ASTM standard, which you can buy for £89, I think.
Yeah.
It's 79, 80 quid. I really should just buy it. But no,
it'd be on a torrent somewhere. Find it on a torrent and publish it.
Well, again, pull up a sandbag. But Patrick and I were on the first ASTM standards call years ago, and then we threw our toys out the cot when they said each standard was going to cost that. So it's not just 80 odd quid for the RID standard. It's 80 odd quid for the motor standard, 80 quid for the battery standard, 80 quid for the. It's like nah. No, that's not how it should work.
And people wonder why de facto standards are so much more popular.
Well, one wonders. Now,
sorry, carry on.
No, you just chat amongst yourselves.
Oh God!
Oh no! Don't tell me
the
hyenas are breaking down the laundry door.
He's left pornography playing on that telly again in the background. That's what it usually is.
It's another lion at the dance door.
Oh, they're
Yeah,
shooting close to him. They're nicking the copper. If you see him go offline, someone's taking his the copper.
Set fire to his outhouse.
Yeah.
Something like that.
It's either that or there's an incoming in Viry Port, South Africa.
That'll be it. Yeah, it'll be one of those urban mobility things.
Yeah.
Did you guys see the link I put in the private chat? Well, that's the opendroneid.org.
Yes, that's the one I'd seen. Yeah, let me just look at it. There's a picture of a field, if I remember, with a device. That's the one. There it is.
Yeah, so if you look that up, if you jump to about 45 seconds, it's me on my phone playing on it.
Oh, that's you. It's your hand.
You can see my reflection in my face is in it.
Oh, I actually referenced this in one of my videos. That's cool. I didn't realize it was you. That's we got you to blame for this all then. No. It's funny. It's all ended up a bit of a mess. And look, the reality is, I think from a government point of view, it all looked very simple on paper. You know, go out and get this legislation. Yes. We want this, we want that. And when it's come to actually implementing it, it's suddenly become a very big handle.
Yeah, so I think the big push why they wanted it was for the basic idea of a police officer sees a drone, someone complains about it, they want to know where the owner is. That's basically the bottom line of what they wanted. And that has so many peripheral and cultural side effects of that. But the police kind of pushed that and everyone went, oh, sure, technologically, sure, we can do that. And they kind of went with it. And then they went, So
we don't need it in the UK. We just kick people's doors in and invade their privacy and arrest them for 3 days and interrogate them and then realize they're nothing to do with it. We don't bother with evidence or anything like that. We just you know.
Wait, you have laws and you follow them?
Yeah. It's the police don't. They just do what they want. But it's interesting. Obviously, we've had various things. You know, you've had a few open source things starting to appear now. We've got the French one that was put on ArduPilot a while back as well. You know, so there's options coming up. I don't think it's going to be in the next 2 years. I don't think we're going to see anything like they were predicting. You know, they wanted it all done by the end of this year. It's not the only thing that could happen is there could be there's a bit of a get out of jail here they can take, and that is if they just get DJI to implement an open standard that they can turn around and say, oh, we've published this, DJI have retrofitted that on firmware for the last 2 years. They can get an overnight win of publicity saying we've done all of this with very little actual action.
Stop talking about him, he's back.
You know, because that's a very quick way. You know, DJI have Aeroscope, which is closed in their own system. DJI could implement something very quickly, which would get a lot of press if they wanted high numbers. Because reality, ArduPilot users, plane users, they're not the problem. It's for the most part, it's the ready to fly stuff they have a concern about.
That was a porcupine, in case you're wondering.
Not the lion this time.
That's a new one.
Come on. We were expecting a lion. Come on, Gary. You disappoint us.
Do you watch the Gary Zoo stream? It's great.
I know. We have the soaring planes to locate the lions. So you just we want a lion on shot.
That was actually for jackal, and it was for serval and genet cats. And we actually did discover something about jackal, which that they can travel anywhere up to 100 kilometers in a week. And they generally go at least 5 kilometers every day back and forth between places. And that was data pulled from a soaring flight because the collars, when you interrogate them, they pull all the data that since they last saw a repeater unit, and then that's what I was doing. So I was just staying on station and listening out for collars, and then pulling all their position reports. So it was.
Couldn't you just sneak up to them while they're sleeping and put a Fitbit on their leg?
Yeah,
it was before Fitbits.
The range is like very short for syncing that. Plus, you gotta stand there and be like, sync my Bluetooth, sync my Bluetooth. Press the button.
Oh, well, you just get them gym membership or something, you know, entice them into somewhere where you could see them every day, you know. But no, that was a terrible study, because really also the main thing we proved was that all these animals get wiped out by people. That's really what we proved in the loss of habitat. But
so we proved something we already know.
Yeah, sadly, definitive proof of it.
The way you ran up there, I was worried. Like, was it like an elephant ringing your doorbell or something?
No, it was the dogs
they ring
going
and then they just walk on in.
Yeah. Oh, again, pull up a sandbag. You got stories about that, but no, when it pushes through the hedge, it makes a hell of a noise when it comes through the fence, bristles, and then the dogs go nuts, and then the thing gets trapped in the fence because the dogs are going nuts. Anyway, you know these. But you have them there. You have them in Arizona, don't you, Tom? They must have them there.
Elephants?
No, porcupines.
Porcupines. Not really in California where I am. I think there are some, but it's not a problem.
Yeah,
two-legged porcupines.
We have skunks. We have skunks. That's a different kind of problem, but yeah.
Yeah, no, that was my 5-year-old loved to see a skunk. Anyway, have we spoken about the DJI thing and why we really should learn how to fly them instead of just?
Not yet, but we should.
The M600.
We killed that topic before the we went live, so we decided
Let's kill it again.
No. We decided that FPV sucks because if someone cannot fly a drone without GPS assistance, most likely he won't be able to fly FPV.
Oh, come on, FPV is so much easier than line of sight when you're dealing with a symmetrical thing like a hexacopter drifting away in the wind. You don't know which way it's facing, and by the time you work it out, it's gone. But I mean, surely the CIA must be really annoyed. There was no risk management. There was no contingency planning. These guys just had no clue. And when the first one crashed, they thought, let's put another one up.
I know. I
can't believe it.
That's a few grand. You know, an M600 is running 5-6K. To dump one of them into the ground and then pull another one out of your pocket makes you wonder who these guys were, really, doesn't it?
Yeah, you know? But the thing is, you're counting only on the birds. You're forgetting about the payload that can be quite more sometimes than the bird itself. It's something that sometimes, and I have to do training to operators of our company systems. And I mostly try to give them the best tips I can, even though they are not good drone pilots. They are licensed by the regulators on the countries, and I've been giving training all around. They are licensed professional pilots by their whatever safety or boards they have in that country. But in the moment of truth that something fails, you must have muscle memory. And it is very important to train that muscle memory. So sometimes I even force errors on the system to make them do the maneuvers, because there's for a drone pilot, when you're flying a drone that is sitting at 150 meters high, you don't have any perception what the drone is facing, what's it doing, because you're looking absolutely with your head tilted up. So you have to develop a muscle memory of do a certain type of maneuver, to be aware of the orientation of the vehicle and then fly it. If it would be FPV, and sorry, Bruce, but from experience, FPV would make them more confused, because they would try to fly towards what they shouldn't. So they have, because usually on those emergency situations, you don't see a thing. So you have to take away from the obstacle and fly only seeing sky. So you have no references. So it's quite different to fly at that high with a drone.
Yeah, but this was only at 100 feet, according to the report. And I'm wondering, should they lose their commercial rating thing, because they've proven that they're incapable of doing the things that are required to get that certification in the first place? And why does the regulator not mandate a practical test? You can't go down and do aviation law and flight theory and then jump in a 172 and fly around until you stop crashing. So why does the thing not have a practical test that requires you to fly in ATI mode?
If only we had some sort of trainer here that could tell us about that.
Yeah, but for instance, in Spain, you have to do manual flights and to get your license. And for some people, the maneuvers that they make you do, like the flying in corkscrew, front facing and back facing, always keeping the drone towards the objective, it's not easy, and you really must know how to fly.
They could just buy a cheap drone and learn to fly line of sight in the backyard. Oh no, you'd probably get told off for that. But just find somewhere you can fly your cheap drone line of sight and learn those skills. You don't have to use a big matrice to learn those skills, do you? But surely there must be, like when you fly an aircraft, you have a BFR. You got to, every 2 years you got to do a biannual flight review to show that you still have the muscle memory and the skills you need to fly that aircraft safely. It seems like that's just not a requirement in the UK. They're more interested in making sure that policemen can tell where you're standing while you're flying.
I can tell you, Bruce, that flying an M600 fully loaded with one of these on FPV, it's a completely different ballgame. It's absolutely two different worlds. You can fly one of these easily. What?
Over to somebody from a school. Mark, go.
Actually, in the UK, what happens is they will do their training, their ground school. You learn air law, you learn the law for everything. You learn human factors. You will do a flight test, okay, to be clear. So the flight test is broken into two sections in the UK. The first part is your practical flying skills. Can you do a certain set of maneuvers? Can you recover the drone? The second part is where we put them through an actual job. So you show up with your aircraft, and typically it will be a Mavic 2 or something like that, or a Mavic. You don't see many Phantoms anymore. And because it hasn't got ATI mode, the CA have not said they have to do the flight test in ATI mode. However, what is meant to happen is you're meant to read the instructions and understand the new aircraft that you're going to fly when you go to fly it, and understand its flight modes. So in the practical flight test, as you're doing your flight test, I or the other instructor or whoever, we will give simulated emergencies. If you lose GPS, or if you can't lose GPS, it could be aircraft incursion, a person incursion, it could be a fire on your drone. We're going to give you all this. It can be public incursions into your landing area. You get all this put at you under a real job, and then you come back and you will land, and you'll either have passed or failed. But the problem, it looks to be like these guys passed on a Mavic. They flew an M600 without taking it out to a training site, learning its flight modes. I'm a big believer in, because a multi-rotor can fly in any direction, you just have to know if you push left and the aircraft goes right, you know that if you push right and the aircraft then goes right, that's the front of the aircraft. It doesn't matter which way is forwards. It doesn't matter which is the back, because you know right is forwards. And if you know right is forwards and you're pushing the right stick, as you yaw it around, it will come to you.
ArcPilot has that flight mode where right just means east or whatever.
Yeah.
You need a working compass for that, though, don't you?
Yeah, home lock. It's called home lock, isn't it? I think.
Yeah, DJ call it home lock. They've all got a version.
Yeah,
of
but
it.
the thing is, you really know, and I agree with you, because when I teach someone to fly a drone, I teach them the left-right maneuver to find where the nose of the drone is. That is the basic one. The thing is, when the drones are very high, you just have 1, 2, 3 seconds to decide what to do, because if the wind is blowing at, say, 10 meters per second, and for instance, we put a operational limit of 10 meters per second to operate our systems, although the systems can fly at higher wind speeds. And usually when you're at the top of a wind turbine, you can face gusts of 15, and the drone is dancing all around. You really have to be pro-efficient to take the drone out, and you don't have the time to think.
No, I think
so.
With something
like the M600, so the S1000 that I fly, basically that the aircraft, this can be the front of it. Okay, so this side can be the front. As long as you know that you're now flying forwards with your controller, this is now forwards. You don't have to know which way the nose is at all because you fly it this way. So if you're flying this way, you know when you give the input, it'll turn like this for you and it'll come round. You need to understand that this is not the front on a multi-rotor because it doesn't matter where the front is. The front is where you make it. So you're 1,000 feet up. You can't tell which way the aircraft's facing, but if you put left input in and it shoots off to the right, you know that you're going, you just put right in and it should then go the other way. That becomes the front for you and you fly it. You're literally going to fly this side now as the front. Where the camera is doesn't really matter, to be fair.
There's a set of events that caused this, and in some ways, having been through the PFCO and all of it, number one is last year, maybe a little earlier, they removed the weight limit, which was in place. So you used to have two band-ins. You used to have a below 7 kilos and 7 to 20. Now, what happened about a year and a bit ago is they removed the middle band-in. So whatever flight test you did, you got the 20. Now, the old system would not have allowed someone to have taken a test on, say, a Mavic and been able to fly the M600. They wouldn't have been able to do it, whereas the current legislation does. An aircraft like the M600, 5 hours on an aircraft that big wouldn't make you necessarily 100% comfortable if you're only ever been flying small aircraft. I don't fly big aircraft that often these days, and I'm extremely touchy when I do, because at the end of the day, it's like anything. You've got to get used to it again. And an M600 is a big old beast, especially when it's in attitude mode and it's heading off into the sunset. Having put a few big hexes up and done it on purpose, the bottom does twitch for a second or two until you're 100% happy you've got it back under control. But I think what's scary here is the chances are the CAA managed to create this situation by changing the legislation. You do have a very basic test, and on mine, I actually did mine with the Inspire 2, which did have attitude mode, and I did use it in my test, but it was basically a hover. It was basically I was able to prove I could keep the aircraft where it was, but that's in a controlled environment. I think the whole thing that's scary about this is the fact, as Gary said, they put another one in the air. Not only did they smash one into the ground, they screwed a second one in as well. And I think it's clear they didn't know what they were doing, but is it really any different from a 17-year-old with $1 million YouTuber who's made all of the money, passing his driving test and going out and buying a Ferrari and then caving that into a wall? No, it really isn't any difference. And whilst you can legislate for everything, at the end of the day, stupid people will do stupid things. And I think that's probably the reality.
I'm proof of that.
Yeah, you are. Well, I reached out to the journalist who everyone seems to be reporting, because David Hamlin actually he quite often asks us questions, and when I pointed, because I think the trouble is reporting. They're sort of reporting as GPS is failing, the whole world will fail, whatever. It's not being reported as numpty crashes expensive toy.
When you read it, it lost. The mag was separate from the yaw. It's compass issue. He took off extra metal. That's what he did. There was he probably looked around and went, "That's a nice drain cover. I don't have to get the legs wet. I'll take off from that." Or it was on the roof of his car or something like that. It's, and reality is, as dangerous as they were, they still didn't kill anyone. So at the end of the day, even when someone does something completely reckless, no one got hurt. So how dangerous
only a matter of time.
Until we find that the people, the garden of the cows that they fell on, some small 2-year-old children that usually play in the garden.
Usually
they got the garden dug for free. What? They shouldn't be complaining.
And it didn't go on fire when it landed. See, what people complaining about? There was no spontaneous combustion.
But if they had been flying at FPV, lots of people would have died.
Yeah.
Yeah.
And spontaneous combustion can occur.
It can't.
I can guarantee.
Yeah, it occurred on my bench 2 weeks ago. Don't worry
What
about
happened when you're walking down the street? That's a spontaneous human combustion. That's a thing, isn't it?
Yeah,
don't hear about that anymore, do you?
You
That
don't,
used to
do
be
you?
quite a popular one, didn't it? Before
That's right.
drones. This is
Before
drones.
cameras.
They've got rid of spontaneous combustion and UFOs. That's terrible, isn't
Yeah.
it? I mean,
But now we've
there's
got drones, so it makes up for it.
yeah. Let's bring those back. Let's have some spontaneous combustion.
I had a lipo spontaneously combust on the bench about 2 weeks ago. Good job I was up here, but yeah.
Now, Tom, you were trying to show us a bit of video of some sort of OSD. What was that about?
I did. This is a thing. This is a thing I made. Gosh, 2013 or 14, 2013 timeframe. And then I got. This is before I started heavy in my drone career.
I hate about software developers. Everything they show is always cool.
So
Hardware
this
guys.
is where the inspiration of this came from. I'm flying out in the middle of nowhere with my friend, and I'm in a quad, and I have a GoPro on it, and I was just trying to film him flying, right? Let's see. So here he is. He's flying around upside down, and I got my little quad chasing him, and I've got FPV on a separate camera, but it's got analog terrible quality video kind of thing, and I can't see him, I lose him, right? So there he is. I turn left, but the plane went right, and I'm like, where'd he go? And then you kind of burn some time figuring out. We're standing next to each other down there, and so we're talking. Oh, I'm this way, I'm that way, and it's like I'm burning my battery on my quad, trying to find out where he is. So I ended up coming up with this thing with a friend of mine, and this is back before I was diving hard with ArduPilot. I was kind of doing Mavlink with ArduPilot a bit, and then also I was still in the Matrix Pilot world, of all things.
Yeah.
So I made this little on-screen display from scratch. Made my own little board, and this is just in a little simulation mode because I had no GPS or nothing. It's on the desk, basically just spinning around all kinds of funny angles. But the idea is it's looking at a target here. So you basically buy this kit, and it was a cooperative sort of FPV thing where you put a little module on your friend's drone and one on yours, and they're talking to each other, and then you both do FPV, and they both show up on the screen. You can see where they're at. And the idea is you could do dogfighting with this, and because the systems knew where they're at and they're lined up, you could actually, score points by shooting at them with like these imaginary lasers and stuff. And
the problem of this, Bruce, FPV always goes to violent behaviors.
It does. I find myself doing that all the time. Like, actually,
Exactly.
this is just like the TBS radar. TBS have got the same thing. They integrate with FLAM, and they'll show you on your OSD where any aircraft are in relation to you. So, like your home arrow, an arrow points off to where the aircraft are.
Right. So it's the idea to start off with that, with a little bottom right here, a little circle with a radar sort of thing, and then with multiple aircraft so you can go chase them. And I thought this would be a nice product. And I kind of worked on this for a few months with a friend of mine, and then I kind of went off and did different things. But I made my little board. I was going to incorporate it, and then I thought, I'll actually get this into ArduPilot and make it an on-screen display to do all this. But I just ended up going different directions on different things. But I did some demos with it. Like real demos where we're flying, and that aircraft had it, and it's chasing around. So this is like it's not an aircraft, but it's like something on the desk outside. And so we're flying it, and it's looking at this thing. But I mean, this was all pretty state of the art for 7 years ago. Nothing was really out there at all for this.
Absolutely.
Yeah, it was before my time at Airframe, and I was just kind of playing around trying to think of an idea. And
see hardware guys, I can pull out a little box which has got an LED that flashes, but it's never as impressive as software guys. They pull out stuff from 4 years ago, and you just sit there and go, oh.
I actually did all the hardware on this too. This is because my background is actually embedded systems. I do low level and medium level stuff.
Well, that's the most interesting stuff.
I had a hissy fit with Honeywell PR stuff this week and I just happened to find this on the desk because they're going on about they're using a helicopter to find QR codes to autonomously land UAM vehicles. What a wonderful idea! Nobody's ever thought of that. Fantastic! It's like, come on, we've all played with that. That's been going for years. And just the reinventing of the wheel that's going on. So whilst I know you're not big fans, but the soaring thing and keeping flying through using thermals or biomimicry made me laugh the other week when your lady said, "Oh, we're using biomimicry." All right then. That's a difference. That's a bit of a change. But there's loads of stuff that's just repeated wheel every week. Oh, we've seen this before, that before. Bruce would know because you've been around since time began, Bruce. So you know these things.
Yeah, Bruce is back. You know, he's back when dirt was new. So the funny thing about that whole thing is when we did our long 12-hour flight, our CTO Stefan Kraus was on earlier. He was jumping around saying, "Oh, world's first, this and that," and it kind of was if you narrow down the scope a bit. So
yeah, you have to caveat.
A lot of people
say it's first. You say it's first ever. And then you say, yeah, then you caveat it later.
It was first ever, and then narrow down the specifics. I mean, there's been other aircraft that we had that have flown 48 hours and stuff, but nothing with more than 2 grams of payload or something. They're always like balsa sticks and stuff that they're just holding together. And then universities did this 20 years ago and stuff. So it's kind of people. It's sometimes you think it's the first, and sometimes you kind of are if you narrow down your criteria like down to something tiny. And so
what we really want to do though is make it more of an accessible technology, so it's not just a academic or university one-off type project, but it's an accessible technology that people can use for fun or for commercial applications.
Yeah, it's like 6,000 feet is fun.
Yeah, well, it's one of those things where it's like, sure, this has been done before, but no one's ever sold one. It's like they're not for sale.
Yeah.
Right.
Yeah.
They've never ever been anywhere near close to like a product. There's been lots of R&Ds and all that. So we're doing the final trials of that, ramping up some stock, and we're going to be shipping some units out from our customers. So we're finally doing it. Pushing that envelope. Yeah. So we're world's first in that sense too, where no one's ever had a glider that's done it and then also brought to market.
You're going to be playing in all sorts of cosmic rays, man. You're going to be playing in all sorts of weird airspace environments at high altitude. And I say the ultraviolet, the materials you're going to need to keep the thing in one piece.
Well, that temperature, that's going to be the big thing, doesn't it?
It's temperature, yeah. Temperature is more of the issue, I think. Although I don't have much experience at soaking our vehicles up at 100,000 feet. Hopefully that's a good problem we have.
Yeah, you're really talking about a space-like environment when you're up that high. The pressures are so low, and if you're in the sun, you're getting superheated, and if you're in the shade, you're getting super cool. One of the big problems that people don't appreciate is that it's cold up there at night, but a big problem you have is actually getting rid of heat as well, because there's very little air to conduct it away. So your internal components can overheat as well, even though it's very cold on the exterior, because there's not that medium to conduct it out. So it's a whole new set of challenges when you're up at that kind of altitude.
So watching the drone going to Mars with great interest, similar environment.
Yeah, very interesting.
Yeah. The funny thing with Mars is the average is about 1%. That's 0.6% of the atmospheric pressure. You can get down to 1% at the lowest points, but it's generally, not much air there.
And
again, how much atmosphere there?
Yeah, there's not great parties. Your stall detection is also going to be super important up there. But then I suppose the flip side of that is the air is not very dynamic once you're up there. Once you're up at 100,000 feet, it's not.
Once you're up super high, 100,000 is a bit extreme. But if you're up at 60, 70 kind of thing, then once you lose lift, you're going to tumble a lot more than what we tumbled. So I'm not sure what the altitude was on that when we did ours, but we're a couple thousand feet up or something. And then, but once you're up really high, then you're just not going to. It's going to take more to recover because you're just kind of falling through less things, so you can't orient yourself.
But how much extra flight speed do you need to maintain the sufficient lift to keep the craft in the air at those altitudes? You must go pretty fast.
Yeah. It increases proportionate to the density.
Yep.
And you're going to end up with an aerofoil and stuff that's probably pretty rubbish at low level. You're going to have to optimize for that high bit, so you climb through. It doesn't matter once you're there and on station, does it?
That's right. Yeah, the idea is that you don't have to launch or recover very often at all, so you can afford to optimize much more heavily for the high altitude conditions.
Yeah. Plus, we've added some new code for doing camber and stuff for all 3 flight surfaces on the aircraft. So automatic camber up and down. So we have like you can change your shape during the flight, and so we actually have some good data on that, where we actually have skewed our the flap camber across the whole thing during flights and do a bunch of tests, and to give us feedback on creating this new aircraft or next generation stuff.
And Richard's saying
it's a Transformers plane, right? It's a Transformers plane. It changes itself during flights.
That's your PR. That's one of the PR angles, isn't it?
Biomimicry.
Biomimicry transformer plane.
Yeah. And then the biomimicry thing and morphing.
Sorry, I prefer the Transformers analogy.
Yeah. Our particular aircraft is odd that it does, or unique in the sense that it can go really slow and really fast. So we've actually clocked it at 230 knots, I think. 240. What was it, Sam?
Yeah, that was it. That was in a dive. So it's a bit of a one-off. It's a bit risky to quote that figure as being its maximum level.
It has achieved it, and the wings do not fly off.
Right. Yeah. Right. It's usually it's more like 80 knots. Really, would be the kind of dash speed.
Yeah.
What you need to do is just stick an RC jet turbine on it. Get a jet cat turbine and stick that on the back of your glider. No, back of your aircraft.
It'll also get you higher too, because the problem is the lift at that point. Propellers only go so well.
Yeah, that turbine will get you there, and it'll still keep going.
No problems with heat. It will eat the entire plane. Just put the jet cat inside the plane. It will keep it warm. Can you use a balloon?
Can you use like a helium hydrogen balloon to lift you to operating altitude and then release from there if you wanted to? Would there be any benefit to that?
The way I like to think about all these problems are, with infinite time and resources, I can do anything.
Why aren't you?
Because I don't have infinite time and resources.
Yeah.
I'm taking donations.
Gary, can you organise that, please?
Oh yeah. Oh, okay. I'll get a box there.
I have a little post-it note right here. It says, get unlimited time.
But one of the things is going under your own power from launch and stuff like that is because a lot of the balloon drops discover they've got a problem with their system at the moment it gets dropped. If you could take off from the ground, you at least may uncover some issues or problems if there are any issues.
It's not so far to walk to the scene of the crash. I mean,
exactly.
We've worked with companies who not only do they launch their aircraft from a balloon, but they don't power it up until after they've dropped it. So that the powering up is triggered by the drop from the balloon.
Yes.
And in this particular case, that didn't work. So they dropped it and nothing happened apart from it fell. So there's definitely risks.
So I have a funny story about the EKF. The EKF in RG-Pilot was very versatile. This has been fixed now. This is several years ago. But we had someone that was flying a bigger model plane and had a little baby plane under the wing, upside down, kind of mounted to it. So they were going to do an air launch, right? I think it was a space shuttle shaped thing or something like that, and they're just glided down. But when it was up there, it was upside down, and they were flying around with like that. It was powered up, and they did all the work around the ground and they mounted it. But the EKF saw the data as it's literally flying around upside down. It slowly learned that and flipped itself upside down. So when it dropped, it thought it was upside down then, and then it couldn't fly.
Oh, man.
Yeah, that sounds like something Dan has.
So it actually self-corrected itself all the way.
Yeah, because they were flying around for 10 minutes or whatever, because it was actually flying, but not under its own power. But it didn't know that.
I was
this AI more blockchain would have fixed that.
Yeah, Bruce Chain. I was watching that video on this Compass thing. This
Bruce
stuff
Chain.
you guys have been working on. Yeah, Bruce Chain. This EKF stuff you guys have been working on with the Compass. I've been watching as well, where it self-corrects at takeoff. That was being shown. I can't remember which that was shown in the videos for the conference last year. wasn't it? Where if there was a compass error at takeoff, it would actually self-correct and then carry on the flight.
Well, plane actually plane does all that because plane usually just uses GPS for the most part.
Look.
Anyway, guys, great discussion. Great discussion. Time's up for me, and I'm afraid. But thanks for having me on.
Yes. Well, thank you. It was one honor. Thank you very much. We'll look forward to watching this with great interest.
Thanks, Sam. And I hope to get this one flying on Ardus Solar.
Absolutely. Yeah, turn it on.
It'll work.
You just need strong enough thermals.
Yeah, that's all.
Yeah, we'll try and get it ported to submarine as soon as we can.
Yeah. Ardu rock, Ardu brick, Ardu stone.
Ardu. No, it's Ardu buoy.
Oh yeah. So what other news?
We Ardu mine because it can float or be below the surface.
Be careful with the word. Does Dom's plane have solar power or battery? It does have it. There is the one you're flying at the moment is just there's no solar at the minute, but the other versions do have solar, don't they, Tom?
So pretty much all of them will have solar, but we have various ones that have solar and not solar for engineering wise. But basically, they're all going to have solar at some point.
And you've got the whole facility to build these up yourselves. This is all built. Everything's in house now. Then.
Yeah. Well, so right now we have a unit that we are buying from overseas, somewhere in Europe. I can't remember the name of the place now, but we have a sail plan that we are modifying. But on our next generation that we're learning from the current one, we're making one from scratch. So we actually have Sam, who's obviously great at soaring background and then has aeronautics engineering background. We have another guy, Tim, who is another aeronautical guy who's much more about like designing the airfoil of the wings and the propellers and doing the whole aeronautics thing properly. So with them, they're basically building the aircraft from scratch. So we have our prototype being built right now on our first mold. So we're getting that getting worked on right now. So we should have that in a few weeks to start retrofitting and doing a maiden flight in a month or 2 or 3 or. Depends on what our other workload is. We're planning on ramping up and hiring some more people. We got more projects in line. We basically have too much work to do right now. It's great. It's a good problem to have.
That's a very good problem to have. Now, Mark, I saw you pull the clipboard out. Then why did you pull the clipboard out? That's a bit of a worry. You're muted. You're muted. Oh, I thought it was a clipboard. You're muted.
Sorry, it was on my iPad. There's a new thing. Apparently, Precision Hawk have just been awarded 2 patents on UTMs.
Oh,
yeah, 4. I saw that.
That's not positive news, but there we are. Another throw of the dice for them. My goodness me! Just how many times can they reinvent themselves? God. Anyway, I'll have to be careful. I'm not going to say anything.
As long as someone finances those things.
Well, that said, I do you see the lad in Australia, Monash, who's managed to get himself a patent awarded for buying 3-4 solar cells from Banggood and putting them on the front of a scooter and saying he's got a solar scooter, because that's basically what it looked like to me. So I did make me think today, we got to patent something. We got to patent something quick, and don't know what it'll be.
Yeah, I should patent that on like a roller skate, and then if you have a skateboard, then you can put it on your cat and your dog.
You call it overboard. You call it overboard, and we'll sell millions.
Yeah.
No,
and you make sure I say first ever on the front.
Yeah. Industry leading, world leading, industry leading,
industry leading, 0 sales.
Breakthrough technology.
Breakthrough technology. That's another one. We've got to have that as another banner. Breakthrough technology. I've got too many banners I'm creating now, but we're definitely going to have that one. Look, did anyone else see anything else that we should talk about before we go? And
well, I know that Louis, since I got you on the line here, the conference in Shenzhen next month. on September 22.
I
heard
I'm
that.
not.
Yeah, I'm not going to, but I hear it's going to happen though. I was kind of surprised about.
Yeah, but I'm not going. Come on.
Yeah, I can't make
September is a killer, and yeah, I'm tasked to go to Brazil. So yeah, work has priority. Sorry.
Yeah, Louis and I were
Brazil.
speaking at the conference last year together.
Yeah.
COVID de Janeiro.
We're not allowed, we couldn't get out of the country. We wouldn't be allowed out. And if you come back in, you could have 2 weeks quarantine, and we're not allowed out. Boom, done.
Yeah. Travel pretty horrible right now.
Well, there's upsides to this then.
Yeah, absolutely. And
It's the introvert's dream.
yeah, it's a crazy time, isn't it? All right, gentlemen.
But that conference was quite interesting because we could see that the guys in China were very serious about UAVs, and we could see we are always speaking about these small toy-like vehicles, and the guys there were thinking big. The 5 meters, 6 meters, 7 meters planes, the very small helicopters, which are way larger than the model type RC type helicopters. Lots of messing around with the flight controllers, lots of things that we know what they're using, but they won't tell what they're using, and they close this open source software and they sell it as their own. So yeah, interesting stuff that you can see on those expos.
No,
and that's not necessarily new, but yeah.
No, Ian, haven't you got another flight controller there that's been sent for review?
Yeah, I've got the Nora arrived today from China, a bit quick actually. It's literally like 3 days. Not quite. That's not gone through my COVID quarantine rule yet. So, but yeah, it has arrived. I've lost it now. It's here somewhere. I'm probably going to stuff that into a plane actually because I need to get out and about. So I'm going to put that one together this week.
Should go on an helicopter, Ian. Those are the best. Those are the best for helicopters.
Yeah, they're pretty. I haven't built a chopper for a while. I might be next year's project. I got to get the rover finished first before I go back into. It's been a long time since I've flown a heli. Actually, it was something with one rotor.
Yeah, but they're very good because they're very resilient to the type of vibrations that the helicopter usually does. So all the helicopter people swears by the older model, and the newer model keeps improving on that type of things.
Yeah, there's a thread on ArduPilot, isn't there, about the tests with the vibration isolation of the various models of flight controller. It's interesting that the foam does behave slightly different on some of them. Again, it's not particularly surprising at the end of the day. Nothing is designed for all applications. What you have is everything will do everything, but some are slightly better at some things, some are slightly better at others, depending on what your own application is.
Yeah.
See, it's just that lattice thing that Precision Hawk have been given patents for, blah blah.
Is that what it is?
It was old.
Yeah.
It was old when it came out. It's blah blah. Oh look, hang on. If I close that arrow, I'll never be able to find that again. I just won't be able to post it in SES News. Okay, never mind. Hey ho, hey nonny. Yeah. Yeah, no, it's just that lattice thing. It's an old system they had, and very much what AirMap were after doing as well. Same sort of thing. Right. With that, ladies and gentlemen, boys and girls, going once, going twice. Anyone else see anything else this week? No, Tom, thank you very much. You guys were fantastic, and we're learning lots of stuff, and I look forward to seeing further flights. Dear viewers, wherever you are in the world, and as they say, wash your hands, be safe. Don't go to New Zealand now because it's all kicking off there. Be safe in this weird time. Look after yourselves, and we'll see you again at 2100 GMT next week. And I'll continue doing these things when I because I always make the news go to whatever at about 3 o'clock in the afternoon. So I'll continue doing little news inserts and get abuse from Bruce, and that'll be good.
Gary,
All
just
right.
a quick question before you finish up. Have you
Yeah.
asked for an update on your complaint to the CAA yet? Or
Which one? Which CAA? Which complaint?
the
Okay,
one
he
in
didn't
New
mention-
Zealand?
Oh, him? His one? No. No. That's
No, I
not
did a complaint. I saw an elder flying dangerously on a garden.
Yeah, I hope Gary laid a complaint too.
Yeah.
Yeah.
No.
Gary started the whole thing.
No, and I filled up the model.
No.
It's
Has Cameron?
You should just click end.
someone
Gary,
choked
just
on it.
end
It's somewhere else.
Just click end on it.
You muted, Mike. Mark, you muted.
No, he's
Has Cameron complained?
too big delay on his audio, eh? Like you got a Vox, but it takes a long while to kick in. Now he's better. That's better, much better now.
Right, that's enough silliness, I think.
It is enough silliness. All right, guys, look after yourselves. The viewers, look after yourselves. Take care. See you all next week, 2100 GMT. Cheers. Cheers to Ireland there, Mac. Bye-bye.